Good afternoon, sorry, good evening, good evening, everybody. The reason I'm saying afternoon is because of the fact that JE Advance is done, and yes, we will be coming with the analysis, but yes, let the paper come. We do not wish to have a memory based analysis because, hello, the IIT Roorkee is going to release the question paper for JE Advance, paper 1, paper 2, both just midnight, so we do not have to wait. So if in today itself, if the paper is coming, so be it. So hello NEET warriors, how are you? Let me just refresh that comment screen so that I can read your comments properly. Yeah, so Ananya, good evening. Anuj Singh, good evening. Yes guys, so super excited. Maxwell, Zia, and after that, Ikra. Ikra, I remember this name. Ikra, good evening. Zia, good evening. Good evening, everybody. Good evening. Good evening. Very good evening to everybody. Now, finally, a restart for NEET at PW NEET English channel. I will be your chemistry educator for the journey till 21st of June. My name is Gaurav Singh Arora. I personally am a graduate, a BTech from NIT Kurukshetra long back in the year 2011. My JE rank was around 6,000, but at that point of time, we had only 6 IIT, so I completed my graduation from NIT Kurukshetra. I have been teaching offline for a long time, since 2012, but yes, thanks to Mother Nature, thanks to Alak Sir, thanks to the PW platform, we are here to help students who are more comfortable rather in learning in English. So with that emotion, with that intent, let us start from zero. Now, before starting, I'm telling everybody, beta, take out your pen and copy. I know out of those 22 lakh students, 50,000 or 1 lakh student will be getting the medical seat. What about the remaining 21 lakh students? I am here for those 21 lakh students. Even if you have scored like really well in your first attempt of NEET, still my lectures will be helping you to gain the confidence again. And those 21 lakh students who are maybe not comfortable in any of the topic, beta, I will be starting from basic. Ikra, don't worry. Okay, so thank you. Beta, I will be starting from the very basic. What is, I am not going to discuss the complete NEET paper. I mean, all the 45 questions involving whole of chemistry. No, my job is to first teach you the content. And yes, obviously, we'll be just focusing on the relevant concept. But yes, those relevant concept from scratch, I'll be teaching. But yes, obviously we have to cover everything till 21st. So obviously the pace will be high, but the recordings will always be there with you. So I would rather suggest everybody to just sit with me with a pen and copy. But yes, after the lecture, have a recording also. In the beginning, I'm telling you whatever lecture notes I'll be giving here, you can download all these lecture notes for free. Obviously, these will be going in the PW app. I hope you remember the RE-NEET test series. You have to join the RE-NEET test series. You will be able to test yourself through those mock tests also, and these lecture notes that we'll be providing to teach you will definitely be helping you for your preparations. So what is the target for today? Beta, we'll definitely do more questions, beta. I just need 500 plus. Maxwell, beta, everything will be done. But yes, because universe has given us a second chance, not in the next year, just within 1 month. So let us explore all the possible options. So sir, what are the chapters you are going to teach today? Beta, we'll be starting with physical chemistry. That is today. Our job will be to discuss mole concept. Why? Because it is physical chemistry basics. But this mole concept, I'll be also adding concentration terms. Why? Sir, concentration terms, there is always at least one question, sometimes two, and this also includes 50% syllabus of your solution and colligative property chapter. So in a way it will be two chapters, class 12 solution chapter 50% and obviously class 11th mole concept. And I will be coupling up with redox reaction. Why redox? Because obviously redox gives you one independent question also, and the idea of redox helps you in the predictability of inorganic chemistry questions also, because who is getting oxidized, who is getting reduced for a D block reaction, those balancing is very much required. So with redox we will also be dealing with the basic inorganic logics, which gains a predictability for a question through the redox analysis. So in a way I'll be dealing with 4 chapters today, but yes, by books it will be physical chemistry basic involving mole concept and redox reaction. I hope so I hope everybody is supercharged. Now I want everybody to write in the comment box your name with an initial DR, because you are going to be a doctor after 21st of January. What doctor? A doctor who has completed his or her MBBS through the Dream Government Medical College. So put in your names, prefix that name with the title, that is a DR, that is doctor. That will also give me a kick, that will also give you a kick. And take out your pen and copy and let us start the process. So chalo. So I am super excited, but I do not see that level of excitement in the comment section. So whoever or whatever number of students are there with us, we have started with PWJ English channel just in the month of October, and initially we used to have just 1, 2 or maybe 3 students, but those students, I mean after the JEE mains examination, many of those students have came to the platform and said, sir, just with 2 to 3 months of rigorous one-to-one contact, because you know what, I will be my comment section will not be over flooded. That means this is a interaction between all the serious candidates and between a teacher who is nothing without your results. So actually we are worth not even a penny without you students. So it is your success that will also inspire us. So yeah, now I can see Dr. Zia, now I can see Dr. Pranath, and now I see Dr. Ikra, now I see Dr. Gayatri. It's perfect beta, perfect. So let's start the process for today. Yes, I will not be wasting your time, but yes, I will be discussing the relevant NCERT basics. So starting with mole concept and redox reaction, this is the first question. I am just giving you 30 seconds. Let us start reading the question together. The question says, choose the correct statement about Dalton's atomic theory. Now, sir, mole concept you are starting, that means we have to start with what is an atom. So the smallest species, yes, Dr. Shafana. So actually Dalton was the person who said that atom is the most simplest species which constitute and makes all the matter exist in nature. And yes, obviously post the discovery of fundamental particles, this theory was disregarded, but still it is there in NCERT. And why NCERT is important? This is a 2024 question. Now again, one point I'm making over here, beta, I am giving you a year, not whether it is NEET, it can be NEET examination also, or it can be JEE mains examination also. Mostly it will be JEE examination, JEE mains question, PYQ. Why? Because sir, JEE main is also conducted by NTA of the same nature. NEET is also conducted by NTA. So you have to practice above your PYQ if you want to score really well for your 21st of June RE-NEET. So I'll be making you attempt those JEE mains questions as well. Now, sir, then why you have not written the paper, whether it is NEET or JEE mains? Because that gives you an idea that it is JEE mains, it must be difficult. No, the question in front of you is not going to tell you whether it is easy, moderate or difficult. You have to judge by yourself. That's why I am giving you the year but not mentioning what exactly the paper, it was JEE mains or NEET. I hope everybody is clear. Now I guess most of you have answered also. So let's check. and then we'll definitely be discussing. So obviously this is option A. Perfect, perfect, bingo. I'm really happy. Now, let us revise what it is. Sir, Dalton said atom is the most smallest particle which constitute all the matter. Yes, it was postulated by Dalton. It is definitely incorrect because post the discovery of fundamental particle, it was disregarded. But because it is given in NCERT, so you should know it. So which is not correct, incorrect. Now make sure you are reading this, which is incorrect. So statement A says compounds are formed when atoms of different element combine in a fixed ratio. So because it is written any ratio, so definitely it is incorrect and therefore answer. But learning the theory also, so why option B is correct? Because it is saying all the atoms of a given element have identical properties, including identical masses, identical every physical and chemical property. It is what Dalton said, that all atoms which are same, which will have same properties, and therefore this is definitely correct because it is correct, so not an answer. C is saying matter consists of indivisible atoms. Yes, Dalton said it was smallest, so because this is correct, therefore not an answer. Option D says chemical reactions involve reorganization of atoms. Yes, that logic of chemical bonding, that why atom exists in nature as a molecule, Dalton said that they recombine, they gets reorganized in one or the another way to form different compounds. But who are the simplest species according to Dalton? Atom. So definitely this is also correct, that they can take part in a chemical change. So this was postulated by Dalton, hence this is a Dalton's postulate, therefore not an answer. I hope everybody is clear with this. Moving to the next question. Now, along with Dalton, there were many other laws like law of chemical combinations. So moving to those law of chemical combinations, what are these law of chemical combinations? First, law of conservation of mass. Mass of reactant will be equal to mass of product, although we know through Einstein, sir, energy and mass are directly proportional. So definitely we know most of these law of chemical combinations are at this point of time not regarded correct, but because we are starting through NCERT, so law of chemical combinations are even mentioned by NCERT, therefore I'm giving it to you. So law of conservation of mass is mass of reactant is equal to mass of product. Law of constant proportion is you form a compound by any method, the the composition by mass. For example, you are forming water through any process, the percentage, the ratio of mass of constituent elements always remains constant or fixed. Like water will be always containing 1 gram of hydrogen, and for 1 gram of hydrogen it will be requiring 8 gram of oxygen. So the because H2O, I guess it is 8 na? Yes. So weight of hydrogen upon weight of oxygen will be 2:16. Yeah. So 1:8. This is law of constant proportion. Now, what is law of multiple proportion? Two elements can form more than one compounds, but if you fix the mass of one element, then the mass of another element which is combining with the fixed mass of the first element always bears a simple ratio, and that multiple simple ratio defines the law of multiple proportion. What is law of gaseous volume? Sir, it was not regarded as it was not based on Dalton's atomic theory. It was independently done for gases. Once people started knowing that PV is equal to nRT, then Gay-Lussac's law and Avogadro's law came into being. So this is nothing but Gay-Lussac's law, that whatever the stoichiometry you can apply the stoichiometry for volume also if the participating species are gases and the temperature and pressure of all the gases are same. But this is Gay-Lussac's law, and Gay-Lussac's law was not based on the basis of Dalton theory. So the question is saying Dalton's atomic theory could not explain which of the following. So it cannot explain the Gay-Lussac's law because it was an independent event. I hope everybody is clear. Now, I have not given a poll for this question because remember why I am here, to bring all the students, the 21 lakh students also with me. So those who are here for a revision, sir, I am already scoring good in my examination, I just want more and more questions. Beta, the revision will help you to revise the content, and maybe you will be taking less time to improve your overall score. And for those who are not at all scoring good, they can learn the theory also. So please be compassionate with that we are here for everybody. Chalo. I hope everybody is with me on this. Chalo. Moving to the next one. Now, sir, how atomic mass is measured? Beta, atom is so small that we measure atom with respect to hydrogen. But because hydrogen do not react with everybody, so IUPAC has defined a reference. The reference is mass of 1C12 isotope. But to make it mathematically equal to mass of hydrogen, we have divided the mass of one atom of C12 isotope with we have multiplied it with 1 by 12, so that this complete denominator is mathematically equal to mass of one hydrogen atom, which is approximately equal to 1.66 or 1.67 into 10 raised to the power minus 24 gram. Now, this denominator we refer as one atomic mass unit, but in the recent time it is referred as 1U. So what is atomic mass? Atomic mass of any species is nothing but its relative atomic mass, which will have no unit, into this denominator, which will be U. And in fact, what is an atom? Sir, atom consists of electrons, protons and neutrons, where nucleus contains the protons and neutrons, collectively known as nucleons. So protons and neutrons are collectively known as nucleons, and electron obviously revolve around it. That means what will be the mass of this atom? Sir, mass of proton plus neutron plus electron. But mathematically, mass of proton is approximately equal to mass of neutron, so they are regarded of similar masses mathematically. And mass of electron is very, very less than. If I give you an exact comparison, then mass of proton or either neutron upon mass of electron is approximately 1837:1. That means if electron has a mass of one apple, then one proton has a mass of 1837 times of that one apple. So if you are going to weigh this one atom, then forget including the mass of electron, just give the mass number. So that's why we generally see that atomic masses are nothing but number of nucleons. But remember this fact, these atomic masses are actually masses of any atom with respect to hydrogen. Theoretically, we write this because hydrogen do not react with everybody, but technically, mathematically, this denominator is nothing but mass of one hydrogen atom. And sir, for every atom, we will have so much of isotopes. So whatever atomic masses we know are actually the average atomic mass only. Although that average atomic mass is approximately equal to the mass number, but still we have to keep this thing in mind that all these masses are average, which is the famous example which signify this, that all these atomic masses are average. The famous example of, I'll come to this question, but the famous example of chlorine. For your periodic table, for your chemical bonding, the basic, for your atomic structure, the basic you should know is, if element is represented as X, then A represents its mass number and Z represents its atomic number, where Z equals number of proton and A equals the mass number, which is summation of proton and neutron. And these masses are always the average. How to guess that? With the famous example of chlorine. In nature, what isotopes of chlorine exist? 35 and 37. It has a percentage occurrence of 75%. It has a percentage occurrence of 25%. So let's say you have gone to chlorine home 100 times. How many times? 35. I mean the brother which is not heavy, the brother which is lighter opens the gate 75% of the time. So 75% of the time, which brother you meet once you visit chlorine? So the younger brother, the brother which is lighter, the 35 isotopes. But out of the 100 times, 25 times who met you, who opened the gate for you? The bigger brother, the heavier brother. So into 37. So if you just take the average, it will come out to be 35.5. So this is the relative atomic mass. So the atomic mass of chlorine will be relative atomic mass into the denominator, which is U. I hope everybody is in sync with the logic. Now, if you are in sync with the logic, let us attempt a question. So I will be giving you, because this involves mathematics also, so I will be giving you 1 minute. That will give me a time to take some breath also. And by the time, you guys should definitely give me the answer. Chalo. I hope we had a good start, and everybody who is serious enough must be enjoying. But yes, beta, enjoy and work to the fullest. Chalo. So let me see those comment section now. Chalo. So people are answering AA. Perfect. Chalo. Zia is answering. Perfect. Chalo. Nice. Very good. Poll is not working. Let me check. Beta, if it is not working, then you can definitely put in the answer in the comment section. No, beta, the answer is 80 AMU, I guess. Let us solve the question. I hope most of you have attempted it. Let us solve it together. So after, okay, so I hope everybody is fine. Chalo. Robin. Chalo. Moving forward. Now the question says 1 mole of atom X has mass this much times the mass of 1 mole of Y. Sir, what is 1 mole? Mass of one atom is measured in U. Mass of 1 mole of that atom is measured in gram. Why? Because 1 U into 1 Na is nothing but 1 gram. So this is the significance of 1 Na, which is Avogadro's number, that sir, U is a very small quantity. So in order to measure all the matter properly, what you definitely require is to measure that substance in a unit which can be weighed easily. So which unit can be weighed easily, sir? Technically, even if you have very small mass, gram can be measured easily. So in order to convert all the masses in a usable form, we require those masses in gram. So that means we have to take a fixed amount of substances. So what is the fixed number that has been quantified by Avogadro? That if you take 1 mole of any species, it will convert its atomic or molecular mass in gram. That's why mass of 1 mole species is also termed as molar mass. Now that means 1 mole as in 1 Na as in 6.022 into 10 raised to the power 23 atoms of X will have the molar mass of X. So molar mass of X is given out to be 0.44 times the molar mass of Y. So this is my equation 1. I hope everybody is with me on this. Now atomic mass of X is, now atomic mass is mass of one atom. So let me write atomic mass of X as AX. Now this is given out to be equal to 2.96 times. 2.96 times the atomic mass of C12 isotope. What is the atomic mass of C12 isotope? Sir, 1 by 12 into atomic mass of C12 isotope is 1U. 1 by 12 into mass of C12 isotope is 1U. So atomic mass of C12 isotope is 12U. So that means into 12U. This directly gives you the atomic mass of A. Now if you know the atomic mass of A, multiply it with Avogadro's number, which is Na. So you will get molar mass of X, which will be nothing but AX into Na. I hope everybody is with me on this. That means I know mx. I can put that value of mx over here. And what I'm asked the atomic weight of Y. So I will be getting molecular mass of Y. So molecular mass of Y will be molecular mass of X, which is atomic mass of X, which is 2.96 into 12U. This is atomic mass of X into Avogadro's number, which is Na. This is molar mass of Y, but I have to divide by a fraction of 0.444. So this is molar mass, but what I need atomic mass. That means this is mass of 1 mole. This is equal to atomic mass of Y into Avogadro's number, which is Na. So I hope everybody can see this Na and this Na has simply got cancelled. So Ai will be equal to just this. So this is the simple multiplication you have to do, and because of this multiplication I told you that I am giving you 1 minute. So once you'll solve it, you will get 80 as your answer. The U thing is written as AMU over here. So it can be written as U also, it can be written as AMU also. I hope everybody is clear with me. Chalo, moving forward, moving to the next question. Acha, I have left one more question or what? Nahi, chalo. Moving to next question. First, let us try this one, and then I'll be giving you the formula to calculate number of moles. I hope most of you know it, but those of you who do not know it, at least try it once. Come on, shoot. Quick, beta, quick. Quick. Options are there. Beta, in such tabular type of questions, always see the options first. So I hope everybody is solving perfectly. Quick. Chalo, perfect. Let me check if few of you have got. Acha, I just have 3 more, I guess 2 seconds more. So I hope you guys have attempted it. I guess the answer to the question is Delhi. Let me see. No. Okay, no worries. Let us attempt it properly. Now, the question says, sir, 16 gram of methane. Then first we have to calculate what? Number of moles. Now what is the formula of number of moles? Sir, number of moles can be calculated using whatever data is given for the given species. For example, if we are given weight of substance, so number of moles is equal to if we are given with number of substance, then number of mole is equal to number of species given upon Avogadro's number. If you are given with the weight of that particular substance, then number of moles will be equal to weight of substance upon molar mass, that is mass of 1 mole substance. Because mass of 1 mole substance is always in gram, therefore you are always required to put that weight in gram. So this is weight of substance in gram upon molar mass. Now, if volume is given, then sir, it will be volume given on molar volume, but molar volume you cannot calculate for everybody. Yes, using gas equation, which is PV equal to nRT, you can definitely calculate molar volume of 1 mole of any gas, but for that you should know the temperature and pressure. Generally the temperature pressure mentioned is standard temperature and pressure. Now according to that standard temperature and pressure, just put the value of STP, because I have PV equal to nRT. So standard pressure is 1 bar, standard temperature is 273 is 25 degrees Celsius. Sometimes it is 0 degrees Celsius, but generally NCRT take it as 273 Kelvin, which is 0 degrees Celsius. So putting that pressure and temperature over here and the value of universal gas constant, you should always learn. Value of R is 0.0821 if we are putting pressure in ATM, volume in liters. Value of R is 0.083 if you are putting pressure in bar. Value of R can also be written as 8.314 if you are taking PV as a work. So it will be this much joule per mole per Kelvin. Yes, R can also be approximately 2 calorie per mole and per Kelvin. But taking STP as 1 bar, molar volume will be 22.7. Taking STP as 1 atm, molar volume will be 22.4. Because standard pressure is technically 1 bar, but NCERT in most of the questions that are thrown to you through NTA, they take standard pressure as 1 atm, and that's why they generally take it as 22.4. You do not have to bother about that, because definitely the question tells you by maybe through the options or something like that. So sir, if we put all those data, we will be getting, because number of moles will be 1, so you will be getting the value of molar volume. So this molar volume will be equal to what? So this molar volume will either be equal to 22.4 at what? If you are putting pressure as 1 atm, and this molar volume will be 22.7 if you are putting pressure as 1 bar. I hope everybody is clear. I hope everybody is clear. Now, what is the relationship between 1 atm and 1 bar? Sir, 1 atm is equal to 1.013 bar. So approximately it is same, but yes, you should know the conversion for good level of mathematics requiring question. So after learning these things, let us apply this. That means, sir, for methane, what will be number of moles? Sir, weight of methane given is 16 gram. Molecular mass of methane is also 16. So number of moles is 1. So if number of moles is 1, then 1 mole of methane, sir, it will weigh 16 gram, not 28. So A is not with P. Sir, 1 mole of methane will have this much of electrons. Now, 1 mole of methane. Okay, let me not calculate electrons over here first, because let me first go to the masses. So A is definitely not P. Coming to Q, sir, 1 mole of methane. Okay, let us calculate electrons also, because ultimately if you just see the option, A is going with P, A is going with Q. So definitely it is not P, so it will definitely be Q. So let us check Q rather. But although you do not have to check, because sometimes this is actual archive a question. So see, option can also help you to save time beta. So let us calculate number of electrons also. Sir, 1 methane will have how many electrons? Sir, carbon will have 6, hydrogen will have 1, but I have 4 hydrogen. So 1 methane molecule will have 10 electrons. So 1 mole will have 10 mole electrons. 1 mole is 6 into 10 raised to the power 23. So this will be 60 into 10 raised to the power 23. Is it showing 60? Yes, sir, 60 point something into 10 raised to the power 23. That means A is definitely Q. So A is Q. You should not check also while doing your examination. Why? You should just check A is not P. Rest options are helping you. So now we definitely know A is Q. Moving forward. B can be R or B can be S, because 2 option is S, so you should directly check S first. So B with S. 1 mole of hydrogen, 1 gram of hydrogen. So 1 gram of hydrogen is half mole, because 1 upon 2. So half mole hydrogen you have. Now it should go with either S or R. So S or R. Let us check S, because S is there in 2 options. So occupy 11.2 liter volume at STP. Sir, 22.4 is for 1 liter for 1 mole. So for half mole it will be half of 22.4, which is 11.2. That means B is definitely S. That means this is cancelled, because B is not R. Now talking about C, so C can be R or C can be P. So C, which is 1 mole of nitrogen, it can be R, which is its weight. So nitrogen weight is nitrogen is 14. So 14 into 2 is 28 grams. So 1 mole will weigh 28 grams. It is saying 32. So no, R is not correct. So then for C, I'll be checking P. Yes, sir. It weighs 28 grams. So C is definitely P. So C is definitely P. That means option D is your answer. This is how you should eliminate, because beta, such questions are definitely going to come in your examination. You have to make a righteous choice by observing whole of the options. Even today, the JEE advanced paper, a paper which is supposed to be very difficult, I have spoken to loads and loads of students. They have communicated this. If you, there were 16 questions in paper 1, 18 questions in paper 2. Out of whatever questions of physics, chemistry, maths they have got, if you have been selective with selecting the easy and moderate questions, they were more than 50% in number. And definitely why I'm saying this is because your NEET examination also, beta, it is having 180 questions, that too in 180 minutes. Because okay, you will be getting 15 extra minutes this time, but you have to be highly time efficient. And how to become time efficient? First, gain the momentum by attempting all the questions which you can do in a go. If you feel you can do it, but sir, I have to write 2 lines, don't write that. Mark it so that you can come back to the question once you have gained momentum by making all the easier questions first. So I hope the process of giving the examination is more important than practicing these things. Obviously with practice only you can gain the confidence, but gain this confidence while doing questions also. So once I'm giving you time to solve the question, beta, kindly read the statement, kindly read yourself. Do not wait for the teacher to read out the question for you, because that creates the major problem. I hope everybody is with me on this. Chalo. So this is the next question. This is exactly a JEE Mains question. I guess my DTP has written the shift also. So let me give you 45 seconds for this one. Shoot. 3, 2, 1. Go guys. Everybody. Quick. Quick. Everybody. Quick. Everybody. Quick. Perfect. Everybody perfect. So obviously we'll not mind all those students who are not here to actually study, but those of you who are here, if you are sitting with your pen and copy, then you are definitely going to enjoy and love this session. It is actually going to make your session, make your, at least these 2 chapters, which I feel maybe giving you 3 or 4 questions, because I will be dealing with concentration terms also, the inorganic logic also involving redox. Chalo, students are answering, so perfectly good, beta. C. Chalo. C. Most of you are saying C. Let us check. I guess answer is Bombay, beta. Okay, still percentage is increasing, so I'm happy, because initially I was having very less percentage of students giving the right answer. So even with few, I'm happy. Beta, answer is actually Bombay. Sir, why? Because the question is telling you among them 10 raised to the power minus 9 gram of the following elements. That means weight of each substance you are taking in gram is same. So which will have the highest number of atoms? Sir, number of atoms upon Avogadro number is equal to number of moles. And sir, number of moles is also equal to weight of substance in gram upon its molar mass. So that means this is a constant. So the species which will be having more moles will be having more number of atoms also. And obviously the proportionality will be, because this is constant for all, so the proportionality will be inversely related with molar mass. So if you want highest number of atoms, that means you want highest number of moles, so molar mass should be minimum. So who has minimum molar mass? Sir, PR. Hello. Now this is a lanthanoid. It may be done to you that the atomic mass is not served. So for that you should know the periodic table. So after lanthanide we have Sina par. So this is that Sina par. So sir, in the 6th period it is just coming initially. Polonium is 6th period but oxygen family, so it will be coming later. Lead is carbon family, 6th period, so it will also be coming later. Platinum is D block but a 6th period element, so it will also be coming later. So who is coming in before everybody? Sir, this lanthanoid. After cerium I have PR. Hello. Hello. So even if the atomic mass is not given to you, you can predict that using the knowledge of your periodic table. So yes, periodicity also, that periodic table formation will also be doing, but obviously everything can't be done in the similar lecture. But yes, so I hope everybody is in sync with the question. Moving to the next one. Attempt this one, guys. Again, giving you, acha, this will be requiring a bit of calculation. So giving you 1 minute for this. Try this one. Again, the same logic, beta. Now, I am deliberately doing this. I am not just point blank giving you questions. I am giving you questions on the basis of the theory that I have taught. And they are not random questions. They are exact PYQs, yes, of JEE mains also. More of JEE mains because I want you to practice more and more. And because JEE mains, once it has become computer based test, it is giving us more questions to practice. Chalo, moving forward. Good. So people are answering. 2C. Casper is saying hello, hello beta. Perfect. Perfect. B, people, some few people are answering B. Acha, I am sorry, beta. I am sorry. The poll will be the poll will be indifferent for this. Why? Because the question is an integer type question, so it has to be an integer. So let us attempt the question directly. So do not write that ABC, but beta, this is an integer type question. So I have given you a poll for ABCD. So don't mind. Let me just minimize it now. The question is saying 0.1 mole of the following given compound weighs how much? Sir, 1 mole will weigh molar mass, whatever will be the molar mass of the compound. So 0.1 mole will definitely weigh so 0.1 times of the molar mass, but the answer you have to report is in dash into 10 is power minus 21. So 10 raised to 0.1 is nothing but 10 raised to the power minus 1 into the molar mass. So actually, the question is just tricking you. It is asking you to calculate the molar mass of this compound, and yes, it is. Most of the student miss where beta. Most of the student miss the miscalculating the number of hydrogen. So let me make that carbon and hydrogen for you clearly. Obviously, oxygen and other elements, you can see this is carbon, but it will not be having any hydrogen because 4 bonds. So this is carbon, 4 bonds, so no hydrogen. This is carbon, 3 bonds, so it will be having 1 hydrogen. This is carbon, so 4 bonds, no hydrogen. So this is carbon, 3 bonds, so 1 hydrogen. So this is carbon, 3 bonds, so 1 more hydrogen. So this is carbon, 3 bonds. So yes, this is dash, so that will be wedge, but I'm not bothered in the stereochemistry because I just have to calculate the molecular formula, molecular mass. So this carbon having 1 hydrogen and this carbon having 2 hydrogens. So I hope you can see carbon also, you can see hydrogen also, and yes, that's why I've given you 1 minute for this question. Once you solve, now rest you just have to do addition and multiplication. I hope I will be giving you this lecture notes, and I want everybody to solve this religiously, but yes, the plus minus you can obviously do and practice by yourself. So I hope everybody is clear with this too. Guys, chalo. Guys, chalo. Perfect. Moving to the next one. Again, try this question, beta. Again, a question involving stoichiometry. Sir, what is stoichiometry? I'll definitely be telling you that. So I guess the poll is stopped. The answer is indifferent because that was an integer type. This is also an integer type question, so I'm not giving you poll for this. Just attempt this. Just attempt this for like take 1 minute. Take 1 minute. Just attempt this. Come on. Shoot everybody. Attempt. The question says you have 4 gram equimolar mixture of NaOH and sodium carbonate. After that, you have to tell that x gram is NaOH, y gram is sodium carbonate. You have to give the value of x, which is the weight of NaOH. Sir, what is given in the question? The total weight. So this is total weight, 4 gram. Both moles of NaOH and sodium carbonate are equal. So this is also N, this is also N. I hope at least most of you have calculated the molar mass. Sir, for NaOH it is 40. For sodium carbonate, I guess it is 108. Just check everybody. Yes, yes, Earth. Perfect. So it is 108 or 106 beta. I guess this is 106. Because sodium is 23, 23 into 2 is 46, plus 12 plus 16 into 3 is 48. So just add it up, I guess it will be 106. So what is the weight of NaOH? Sir, weight is equal to number of moles into molar mass. Sir, molar mass we also know number of moles, because in the question it is saying that it is equimolar. So both will have equal moles. Let's say that moles is N. So weight of NaOH will be 40N. Plus weight of sodium carbonate will be 106 into N. Sir, this is weight of NaOH, which is X in the given question. So weight of sodium carbonate is Y in the given question, but I have taken them in one variable, which is N, and the total weight is given out to be 4 gram. So I hope now this is just you will directly add it. So this is 6, this is 4. So 146 N is 4. That means N is 4 upon 146. Do not solve it over here. Why? Because you do not want the value of N. You want the value of X. So value of X will be 40N. So 40 into this value, which is 4 upon 146. So I guess this can be solved easily, and obviously the numerator is 160, the denominator is 146. So sir, this is 1 point really something, because I have to report an integer. So your nearest integer will be 1. Your nearest integer, because it will definitely be less than 1.5. So as per the significant figure value also, your answer should be integer 1. I hope everybody is clear with this. Chalo. Moving to the next one, guys. Attempt this one. Now this is a multiple correct, so I'm giving you 45 seconds for this. Shoot beta. Your time starts now. Please sit with a pen and copy, everybody. I hope the time constraint will also help you to get the feeling that what one feel while giving an examination. So learn the theory also and practice also. Chalo, perfect. Perfect. Try beta, try. I will be giving you whole of these lecture notes. And with these lecture notes, chalo, I hope, yes, people are giving correct answers, so I'm happy. Perfect, beta. Chalo. Still, the percentage is increasing gradually. We can always be hopeful. Yeah, Arth Pathak. Perfect, beta. Pathak ji, perfect. Now the question says 5 mole of AB2 weighs this much kg. Sir, I need weight in gram. So 1 kg is 10 is power 3 grams. So 10 is power 3 and minus 3. Sir, do not see this 10 is power minus 3. Do not see this k. Although whatever answers you are having is also in kg. So don't even bother about seeing the kg and 10 is power minus 3. You can remove them from the given data also and from option also. Beta NTA intentionally do this so that to hamper you, to deceive you from seeing a very simple question. Sir, let's say atomic mass of A is small a, atomic mass of B is small b. So what will be molecular mass? Sir, add the masses of atoms. So for AB2, the atomic mass will be A plus 2B. Sir, mass of one molecule is molecular mass. So 5 mole will have, sir, mass of 1 mole is molecular mass in gram. So mass of 5 mole will be molecular mass of 1 mole into 5. So for 5 mole, mass is given out to be 125. So for 1 mole, it will be 125 upon 5. That means it is simply 25. So this is my equation 1, as in A plus 2B is 25. What about equation 2? 10 moles is measuring 300. Sir, so 1 mole will weigh 30. And what will be this molecular mass? Sir, twice of A plus B. 2 is coming out to be common because 2A plus 2B, so 2 common. This is equal to 30 because 10 is 300, so 1 will be 30. That means A plus B is nothing but 15. This is equation 2. You just have to solve equation 1 and 2, and definitely most of you have got the answer also. You will be getting C as your answer. Good. 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 Chalo. Perfect. Moving to the next logic beta, which is stoichiometry. What is stoichiometry? I eat 1 bowl of dal or maybe vegetable, and with that 1 bowl of dal and vegetable, I can finish, let's say, 3 chapatis. So with 1 bowl of dal, I can eat 3 chapatis. So with 10 bowl of dal, I can eat 30 chapatis. If I give you 10 bowl of dal and 10 chapati, then obviously, sir, you are giving me more of the vegetable and dal, so I need more chapati to eat. That means whatever reactant is limited is called the limiting reagent, and that reactant decides that what product is going to be formed. It decides, as in you will use the stoichiometry of that reactant which is in the limited amount. That is called the limiting reagent. And how to do the stoichiometry? The stoichiometry is nothing that we have learnt in class 10th. You just balance a reaction like this is combustion of benzene. So 1 mole of benzene require how much oxygen? Such 7.5. So just the same analogy. With 1 bowl of dal, I can eat 7.5 chapatis. And 6 moles of CO2 and 3 moles of water can be produced. The stoichiometry, these coefficients are called stoichiometric coefficients, which are obviously stoichio in Latin is element, metry is measurement. So we have recovered these coefficients by balancing the reaction. And sir, in the question, if weight of this is also given and weight of this is also given, then first we will calculate the number of moles and we will check that whether this is sufficient for this. If somebody is not, then that becomes my limiting reagent and the product will be produced according to that limiting reagent. Like for example, if oxygen will become our limiting reagent, for example, so I will be using this stoichiometry. I will be saying 7.5 if I would gain 6 moles of CO2 and 3 moles of water. So for your mathematical calculations, always count for 1. So 7.5 gives 6. So 1 will give 6 upon 7.5 and 1 will give 3 upon 7.5. Whatever moles are provided to you, just multiply those moles. Let's say moles of oxygen given is N, which is limiting. So moles of CO2 produced will be into N. Moles of water produced will be into N. So these will be the number of moles produced. Most of the time in the question, moles are not asked. Rather, they asked weight of CO2. So moles, you know, equated it with weight of CO2 upon molecular mass of CO2, which will be 44. If volume of these water vapors are asked at STP, so moles, you know, it will be equal to volume of water vapors upon 22.4, because generally the molar volume at STP we take as 22.4. I hope everybody is clear with this. Now let us try. Okay, this is just the limiting reagent logic which I already told you. Like for example, I have methane 1 mole, sorry, this is ethane requiring 3.5 oxygen molecules producing 2 mole of CO2 and 3 mole of water. Now, if I have 30 gram of this and 64 gram of this, now first calculate moles. So moles of ethane will be equal to given weight upon molecular mass. Now C2H6 is 12 2 ja 24 plus 6 is 30. That means how much moles I have for ethane? Sir, 1 mole. So what about oxygen? Its moles will be given weight, which is 64 upon molecular mass. For oxygen it is 16. So for O2 it will be 32. So how many moles I have? 2 moles. For 1 I require 3.5. So I have 1 over here, but I do not have 3.5. I have 2 moles. So because 2 moles is less, that means this will become my limiting reagent. So how much of CO2 will be produced will be decided by whom? Sir, by CO2. So CO2 will be your limiting reagent. So you will not say 1 produce 2. You will say 3.5 will produce 2. So 1 mole will produce 2 upon 3.5. 3.5 produces 3 of water. So 1 will produce 3 upon 3.5. But how many moles I have? Sir, you have 2 moles. So weight of CO2 or moles of CO2 produced will be into 2. Moles of water produced will also be into 2. So these are number of moles produced. I hope everybody is clear. Now, if question is asking you weight, so equate the weight formula. If it is asking number, equate the number formula. If it is asking volume, but remember, if it is asking volume, then the volume should be mentioned that it is a gas, and it should be mentioned that the gas is present at STP. I hope everybody is clear with this. Chalo. Let us try questions now. I have given you the theory. So a bit of calculations you have to do, but I am still giving you 45 seconds. Let's try beta. Quick, everybody. Quick. Sir, can you make short video of DNF block coordination if possible? First, for physical chemistry, we have, okay, you are saying you want for inorganic. Beta, yes, Gokul, considered beta. In fact, the next session when I will be meeting, I guess it will be on 19th or 20th, because tomorrow you have Ambika ma'am's session. Post that, you have, I guess, Shubhrat sir or my session. So whenever I'll be coming for the next session, I'll be picking inorganic chemistry. Don't worry. Your wish is our command. No worries. Chalo. Most of the students are answering B. Perfect. Chalo. Let's see. I guess time is also passed. So because most of the students are saying perfect, now I am getting the vibe. So perfect, my warriors. Perfect. So let us attempt it. Question says combustion of glucose. So this produces CO2 and water. So then you have to first write the reaction. So C6H12O6. Combustion as in reaction with oxygen forming CO2 and water. First balance the reaction. So sir, this is 1. So I'll be getting 6 for carbon. So I'll be having 6 moles of CO2. Hydrogen is 12. So I'll be getting 6 over here, which will make hydrogen also 12. Sir, what about oxygen? So this is 12 and that is 6. 12 plus 6 is 18 oxygen I have on right hand side. Now 6 I have over here, so I just need 12. So for 12 I'll be using 6. So now I have stoichiometric coefficients. Now the amount of oxygen in gram required, so you have to give the mass of oxygen required in gram for making 900 gram of glucose. So this is weight given as 900. So moles will be, I hope everybody remember, you should always remember such some data. Molar mass of glucose is 180. That means how many moles you have, beta? 5 moles. So 1 requires 6. So 5 will be requiring 6 into 5 is 30 moles. But you are not asked moles, beta. You are asked weight. So weight will be equal to weight upon molecular mass. So 32 into 3 is 3 is 2 is 6, 3 is 9. So 960 is your clear cut answer. Now this is a JEE mains question, beta. So my point is practice a very doable question, and yes, I have got 100% attempt also in this one. So yes, but what will save you from this question. Why I'm saying save? You may attempt it correctly, but beta practice so that you take less time to do such questions. Chalo. And sir, what will make us take less time? Practice. So what are we doing over here? Practice. Sir, I didn't know the concept before. That's why I've told you the concept first, and then I'm making you practice the question. So I hope you are getting the benefit. But for that, you have to sit with pen and copy, read the question by yourself. Guys, please. Reading question is most important, guys. Chalo, perfect. Perfect. So now I have a fuel. Just read the theory, beta, because theory is going to help you like anything. Chalo. Most of you are saying C. Most of you are saying C. I hope the time also is done. Yes. So let's see. Yeah, perfect. So let me make it quick because most of you have even answered it. But beta, again, a question which require your attention because you need to focus on the statement given. So if a rocket runs on a fuel, so this is the molecular formula of a hydrocarbon acting as a fuel. And liquid oxygen, so sir, combustion. The weight of oxygen required again, but here you are also supposed to calculate the weight of CO2 produced for every liter of fuel. Sir, liter, then for volume I need that species to be gas and at STP, sir. It is not given at STP. In fact, it is a fuel which is, sir, generally we see a fuel is in liquid state. Yes, it may be liquid, it may be gas, we do not know it. Then what shall we do? We cannot, first thing is you cannot use the formula for number of moles is equal to volume upon molar volume. Why? Because you do not even know it is gas or liquid. Moreover, if at all it is a gas, STP is not given. Then, but sir, density is given. What is density? Mass upon volume. So 1 ml will weigh this much of gram. So 1000 ml will weigh, so this much into 1000 gram, as in 756 gram, because this is 0. So if you multiply it with 1000, you will be getting this much of gram, and this much ml is nothing but 1 liter. So actually you know the weight of the fuel given. So what again you have to do? Just write the balanced reaction. Let me write the balanced reaction for you at least. C15H30 plus oxygen will give you CO2 and H2O. Rest of the things are just the same. Sir, if this is 1 mole, so I'll be getting 15 over here because carbon will be balanced. This is 30, so again I'll be getting a 15 over here. Sir, oxygen, 15 into 2 is 30, 30 plus 15 is 45. So this will be 45 by 2. I hope everybody is clear now. Sir, weight of the fuel is given. So its moles will be given weight, which is 756 upon molecular mass. If you just calculate it, 15 into 12 plus 30 into 1, I guess it will be coming out to be 210. So these moles will be, I guess it is 3.6 moles if I'm not miscalculating it. So 1 will require 45 by 2 moles of oxygen. So 3.6 will require how much of oxygen? So 45 by 2 into 3.6. These are the moles of oxygen required. And what is the moles of CO2 produced? Sir, 15 into 1 will produce 15, but 3.6 will produce into 3.6. So these are the moles of CO2. What are you asked? Sir, weight. So weight of oxygen gas required will be these moles. Let's say this is N1. So number of moles into molecular mass, which is 32. 32 into this will be your answer, which most of you have obviously. Yes, it requires calculation, and beta in your examination also such questions are thrown at you. So shall you do such questions in the first go? No. Attempt let's say take 1.5 hours. Initial 1.5 hours take for browsing through all the immediate doing questions of physics, chemistry, and biology. After the 1.5 hours or maybe 1 hour 40 minutes, then the remainder of the time you should invest in such questions. I hope everybody is clear with me. Chalo, perfect, 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 guys, perfect, beautiful. Chalo, try and attempt this one. Come on. Again, you have to read the statement, so I'm giving you 45 seconds for this as well. Shoot. I hope you can make the time count for you. Come on, perfect. Pathak ji is saying best PYQ. Okay, thank you, Pathak ji. Chalo, perfect. I hope I will be getting more active participants. Although I even know that many of you will be watching this in a recorded format. So for all those students who will be watching in the recording also, or maybe who are here live, beta, if you're there live, please. Yes, Pathak ji, perfect. 100 gram per mole. Perfect. Perfect. Acha, the timer is of no use because poll is of no use because this is just an integer type. So again, I am sorry, but still the logic will be with us. So 1 gram of this carbonate on treatment with excess of HCl. What does excess of HCl mean? You do not have to worry about HCl being in limiting amount because it is provided in excess. So complete carbonate will be reacted. Sir, now just the inorganic knowledge, a basic inorganic knowledge you should know that H2CO3, which is carbonic acid, is not even a weak acid. It is also an unstable acid. It forms and decomposes to form CO2 and water. So metal carbonate will form metal chloride because this is 2. That means carbonate is -2. So oxidation state of metal is definitely +1 because carbonate has valency, there is only one carbonate ion. So valency factor for metal is 1. So the chloride will be MCl plus water and CO2. I hope everybody is clear. Now let us balance the reaction. Sir, you just need 2 metals, so I'll be having a 2 over here, and to balance chlorine I'll be using 2 over here. So this is just the single thing that you have to do, which will tell you that 1 mole of this carbonate will be requiring 2 moles of HCl. So 1 gram will have how much of moles? Sir, given weight upon molecular mass. Now the molecular mass we have to determine. So let's say that is M. So 1 mole requires 2 moles and produces how much of CO2? Sir, 1 mole because it is also balanced. Carbon is the remaining reaction is balanced. So 1 mole produces 1 mole. So N moles will produce N moles. This is the value of N. So this is the moles of CO2 produced. But the question is telling you that the moles of CO2 produced is nothing but 0.01 as in 1 upon 100. So clearly M is nothing but 100. So a very doable question. Again, a 2023 question. So I hope you are in sync with the question. And if you are, now there are some other type of questions. Again, an integer type question, beta. So I guess I can give you integer type option also. So my bad. 1 minute for this one. Now you can answer this because I have given an integer type option now. So you can definitely give me an integer type answer for this one. Shoot, beta, try. Everybody, let us gain that confidence together. Let us crack that examination together. Let us excel together. Good, perfect. Perfect. Aha, Pathak ji is on fire. Pathak ji, All my blessings to you, beta. Chalo. Good. If you are actively learning anything, na beta, universe is definitely going to reward you. Perfect. Good. Everybody who are sitting with pen and paper and actually trying to gain something, actually a lot of thing from the given constraint time, because this is what makes the difference between a good doctor, a disciplined one, and rather a non-disciplined one. Perfect, guys. Perfect to all the students who are attempting. Perfect. Now, the question says, I hope the timer is also okay. So let me first give you, I guess, answer. This is also coming out to be 100. This is also coming out to be 100. Chalo, no worries. Let us attempt it together. Let us attempt this together. Chalo, perfect. I cannot see answers in the comment section. I hope most of you have got the answer, or maybe you will be calculating. So let us do it together. The question says, when 0.01 mole of an organic compound containing 60% carbon. Okay. So you have an organic compound, you do not know its molecular formula, but it is saying 60% is carbon. Now, it was burned completely. So complete combustion of hydrocarbon will completely give you carbon dioxide and water. So how much carbon dioxide you are getting? Sir, 4.4 gram. Sir, if I have whatever carbon in my organic compound, it will be hydrogen. It may have any other stuff. I do not know it. But whenever you make it react with oxygen completely, it will form CO2. And whatever is the carbon content in it, the same coefficient you will be getting over here, because 1 mole of this will be producing X mole of CO2. 1 mole of CO2 will have 1 mole of carbon atom. So X mole will have X mole of carbon atom. That means you just calculate the moles of CO2, which will be 4.4 given weight upon molecular mass, which is 44. So what is the moles of carbon you have? 0.1 mole. This is definitely moles of carbon also. Actually, this is moles of CO2, but this moles of CO2 will also be moles of carbon, and these moles of carbon are coming from where? So this is nothing but principle of atom conservation. Atom cannot be created nor can be destroyed. Whatever amount of carbon atoms you have over here will definitely be in the form of CO2. One CO2 will have one carbon, so n moles of CO2 will have n moles of carbon. So I know moles of carbon, that means these are the moles of carbon present in this compound. Now you have to find molar mass of this compound. So let's say molar mass of this compound is M. This molar mass out of the complete mass, 60% is carbon. So 60% of M will be 0.6 times of M. 0.6 times of M is sir, this is the weight of carbon. Sir, I know weight of carbon, and here I know moles of carbon. So can you calculate weight of carbon also? Yes, sir. Mole is this much. So weight will be moles into atomic mass of carbon. Number of moles is 0.1. Atomic mass of carbon is 12. So this is the gram weight of carbon in gram, and this is the weight of carbon in gram from the organic compound. So let us equate it. So it will be equal to 1.2 gram. I guess this is also quite easy to calculate. So this is 1.2 upon 0.6. That means this is simply 12 by 6. So this is 2. So value molar mass is 2. Eh? Acha, okay. Beta, when 0.01 mole, so this is not 0.01 mole. This is this much gram of CO2 I am getting from this much mole. So 0.01, one more iteration you have to do over here. One more iteration, beta. This is the weight. What is the weight produced? This is the weight produced. This is the weight of carbon produced by 0.01 mole of organic compound. So 0.01 mole is producing this much. So if I had 1 mole, what will be the weight of carbon produced? Sir, weight of carbon produced in that case will be this much, which is 1.2 upon 0.01, because this much mole is producing this many gram of carbon. So 1 mole will produce this much upon 0.01. I hope everybody, the mathematical thing you have to do. So this is 100. So this is 120 gram. So actually weight of carbon given by 1 mole of compound is this much. And that you have to equate. So it has to be, this thing has to get equated. So it will be 120. So I guess 120. So this in that case will be 120 upon 0.6. So this is 1200 upon 6, as in 200. So this brings you with 200 gram as your answer. So your molecular mass will be 200. I hope everybody is clear with this. Beta, reading question properly is a thing. What we have missed in this question, the question said 0.01 mole of organic compound. What we have taken in our mind, we have taken 1 mole. So reading language will definitely help you to not attempt a question incorrectly, because rather you can land with a negative mark if you would have not read the initial statement. I hope everybody is clear with me. Chalo. Moving to the next one. Chalo, attempt this one, guys. Again, I'm not giving any poll for this one because again, this is a integer type question. Try this one. Good one, everybody. I guess now Earth is giving me the answer. Perfect, Earth. Perfect. Sir, when will Arjuna batch start? Beta, soon enough. Kumar, soon enough. Chalo. Let us attempt the next one, beta. Chalo. I hope most of you have got the answer. Chalo. I hope you read the question, beta. I'm giving you time to read the question because yes, that creates a problem because people don't read. The language is getting comfortable with the language, beta, is very, very important. So try to read the question by yourself. Now, the question says you have to consider this reaction, and if 72 millimole of PbCl2, so this is one of the reactant which I am supposed to do stoichiometry for, is mixed with 50 millimoles of ammonium phosphate. So this is the stoichiometry of the another reactant. Then the amount of lead phosphate. So this is the stoichiometry of the product formed. So we have to give the stoichiometry of the product formed, and we have to give in moles only. So just the pen will help you. How, sir? First, identify the limiting reagent. The 3 requires 2. So 1 will require 2 by 3. I hope everybody is clear. Calculating with 1 is most famous because it will give you a mathematical edge also. So 3 requires 2. So 1 will require 2 by 3. How many PbCl2 you are provided with? 72. So 72 will require how much? Sir, multiply 72. So 72 moles of PbCl2 will require this many moles of ammonium phosphate. What is the value? So 3 2 ja 6, 3 4 ja 12. So 24 into 2 is 48. Is 48 moles or millimoles. So 48 is the number. What number I am given? Sir, 50. Sir, this is more. If this is more, then definitely the other one is limited. So this is my limiting reagent. This will be remained. 2 millimoles will be unreacted. It will be left unreacted. So what is my limiting reagent? PbCl2. So who will decide the product? PbCl2. So whose stoichiometry I should use? PbCl2. So 3 will produce 1. So 1 will produce 1 by 3. So 72 will produce into 72, which is definitely 24. So this is my answer. So 24 millimoles is your clear-cut answer. A very probable question. Perfect. Perfect, Arth. Perfect, everybody who are giving. Perfect. Perfect. Yeah, perfect. Chalo. Moving to... perfect. Perfect. Moving to the next one. Now, coming to those two laws which are not a direct conclusion of Dalton's theory. The other than laws of chemical combination, what we have laws of chemical combination are Gay-Lussac's law and Avogadro's laws also, but they are not direct outcome of Dalton's atomic theory. Avogadro law says that whatever stoichiometry you are doing for moles and number of molecules, you can even do it for gas. But you can even do it for volume. The stoichiometry you can even apply for volume. But when you can apply for volume? When the participating species are gases and all the gases are at same temperature and pressure, then you can definitely say that 3 liter of hydrogen will react with 1 liter of nitrogen and produce 2 liter of ammonia. NH3, this is NH3, this is hydrogen and this is nitrogen. So I hope you are getting it. That means, sir, here you do not have to calculate moles. You are directly doing it for volume. Yes. Why? Because participating species are gases, and once it is true, then we know, sir, PV is equal to nRT. So once pressure and temperature is same, then volume is proportional to moles. So whatever stoichiometry you are applying for moles, you can apply for volume as well. This was postulated by Gay-Lussac's law, gaseous volume, a highly probable question because sometimes stoichiometry question throws you with volume and people start calculating, sir, I can not calculate number of moles because volume bond 22.4, I did, but it was wrong. Beta, you should not apply P equal to volume bond 22.4 because in such questions it is not given at STP. Rather, do the stoichiometry for volume only. Why? This is what you have learned through the logic. You know it from PV equal to nRT also. You know it through Gay-Lussac's law also. Moving to Avogadro's law, it is also saying for gases, if pressure temperature is same, then whatever you do for moles, you can do for number of molecules also. Obviously, why we know this? Sir, because whenever pressure and temperature are same and we have participating gases, then according to PV equal to nRT, pressure and temperature constant. So you can obviously have for gases that number of moles will be proportional to number of gaseous molecules. So Avogadro law equal volume of gases, it is also equal volume as in number of moles will be proportional to volume. So instead of number of moles, I can say number of molecules also. So number of molecules will also be proportional to volume. So ultimately, these are all conclusions of PV equal to nRT. I hope you can keep this thing in your mind because directly applied in question. So what type of questions? An example. Again, a JEE mains question from 2024. Very, very probable for your paper as well. So please have a attempt in this one because it's an integer type question. So I'm giving you 45 seconds to attempt this. Shoot. 3, 2, 1, go. Come on, beta. Come on, everybody. Chalo. Come on, shoot. Perfect. 14. Perfect. 14. Very good. Very good. Rafish. Very good. Arth. Perfect, beta. Chalo. Let's try. Let's try. Chalo. Perfect. Perfect, Arth. Now, the question says, I guess time has also ended. Students are answering 14. Yeah, good. Good, people. Good. Proud of you. Moving to the next one. Moving to this one. 10 ml of gaseous hydrocarbon on combustion gives 40 ml of CO2 and 50 ml of water vapors. Sir, do we have to calculate? No, do not calculate number of moles, because gaseous, and for gaseous component you can do the stoichiometry. For volume, a direct application of Avogadro, of Gay-Lussac's law. So gaseous hydrocarbon, let's say it is CXHY combustion as in CO2. So it will produce X CO2 and Y by 2 of water. I am not even interested with oxygen because there is no case of limiting reagent. So why bother balancing for oxygen as well, because I know complete hydrocarbon is getting decomposed. So 1 ml, sir, why you are saying ml? Because volume is in ml. So I'm using the stoichiometric coefficient for volume directly. So 1 ml when undergo complete combustion will produce X ml of CO2 and will produce Y by 2 ml of water vapors. Are you burning 1 ml? No, sir. I am burning 10 ml. So how much CO2? So 10x will be produced. How many water? 10 into Y by 2, as in 5Y will be produced. Is the volume given to you? Yes, sir. For CO2 it is 40. For water vapors it is 50. That means X is nothing but 4. That means Y is nothing but 10. That means molecular formula is nothing but C4H10. You have to give the value of total number of carbon and hydrogen, that is X plus Y. So this is 10 plus 4 as in 14. Beautifully done by most of the students. Moving to next one. Attempt this one, beta. Again an integer type question. I'll not be giving you much time for this. So again, not 1 minute 45 seconds. Shoot and try to match the pace for your examination. Shoot. Shoot. Perfect. Mohammadin 14. Perfect, beta. Chalo. Now, the question is given to you in the above reaction. This many gram of benzene on nitration gives this much gram of nitrobenzene. Now, I am coupling all the type of questions to you, beta. Now, this is a question which provides you to calculate the percentage efficiency of a reaction, because it is telling you that this is the weight of product produced. So this is the weight produced experimentally. So this is your experimental value. What you calculate is theoretical value. So efficiency is 100%, that whatever theoretically is coming, experimentally that much should also be produced. But let us now calculate it theoretically. Experimental value is given. The ratio will give you the efficiency, the percentage yield of the product. So benzene undergo nitration. Who will be the electrophile? Sir, NO2 plus. NO2 plus will be substituted. Hydrogen will be gone. So this C6H6 will be forming C6H5NO2. I hope everybody is clear with this. Now, 3.9 gram of benzene. So moles of benzene will be 3.9 upon 78. I hope everybody, this is just 1 by 2 as in 1 by 20. So these are the moles. Sir, 1 will produce 1. So N will produce N. That means moles of the product produces also this much. So what shall be the weight? So number of moles into molecular mass. Just calculate molecular mass of C6H5NO2. Let me help you with the molecular mass. So the molecular mass of the nitrobenzene product will be, I guess, 123. Just check, everybody. It will be 123. So the weight of product produced theoretically will be equal to just, I mean, this is 12.3 upon 2 as in 6.15 gram. So this is the theoretical weight. Experimentally, this much, sir, 6 gram is not getting produced. No, that means efficiency is not 100%. So what will be percentage efficiency, sir? Weight produced actually, which is 4 grams, 4.92 as in 5 grams, upon weight produced theoretically. If efficiency is 100%, then 6.15 grams should be produced into 100. So I guess once you will solve this, has anybody solved it? Once, yeah. So into divide, beta I'm not doing, because obviously it will bring my class to much of a duration, and that will be hampering your time. So I want to be efficient also. But yes, once I am done with this class beta, go to WhatsApp channel PW NEET English. I will be down, the lecture notes will be there. You can download these lecture notes, and please do complete calculation post this class. That will actually give you the right confidence, because these are my concepts right now. When they will become yours, once you attempt by yourself, when I'm saying attempt, do the complete calculation by yourself, because these plus minus are the biggest hurdles that creates the difference between a successful doctor, a doctor getting an MBBS from a government medical college, or other way around. So I hope you are getting what I'm trying to tell you. Moving to the next one. Now, next topics beta, we have acha, I have not seen the answer, but let it be, I guess. Okay, let me just put an end to this. So no responses, no worries. Chalo. Now coming to the next, beta poll, let it be, because we have loads of tasks to do. So let us finish that task. So coming to the next topic, which says, beta, in your question, in your paper, many of the students are confused with the idea of density. So first of all, let me define the different type of densities that you can see in your examination. One density you know from your physics basics. Mass of substance divided by the volume occupied by that substance. So density is simply gram per ml or kg per liter, which is mass per unit volume. Water, you should learn this value. For water, density is 1 gram per ml. Generally, yes, after 4 degrees Celsius, the value change, because tetrahedral arrangement gives water, brings that water to form a crystal ice, and that tetrahedral ice crystal gets introduced with air gaps. So actually, density decreases. But yes, in general, for water, for liquid water, density is this. So this is the absolute density, where you will be having this unit also. Now, one type of density is called specific gravity. Whenever you have a liquid, then specific gravity is generally used for all those solvent whose density are estimated with respect to universal solvent water. So that means density of any liquid upon density of water. Yes. So that means specific density will have no unit. Very important point. So specific gravity is density of any liquid upon density of liquid water, and obviously because this is ratio of same physical quantities, so it will be dimensionless. In the similar manner, for gases as in for vapor, their density with respect to simplest gas, which is hydrogen. So for gases in general, the relative density is called vapor density, which is density of any gas upon density of hydrogen gas. Through PV equal to nRT, you can obviously see that density of gas can be written as pressure into molar mass upon RT. So if you do this, pressure into molar mass upon RT for any gas, pressure into molar mass upon RT for hydrogen. So pressure and RT will be getting cancelled, so it will be molar mass of that gas upon molar mass of hydrogen is 2. So vapor density will be equal to molar mass of that gas upon 2. Obviously vapor density will also be dimensionless. Specific gravity will also be dimensionless. I hope everybody is clear. Perfect. Moving to the next one. Next type of questions that you can get is calculations of percentage composition. Very rare, but yes, because you have to be vigilant with the type and variety of questions. So how to calculate percentage composition? Suppose you are given the molecular formula of a compound. Let's say you have ethanol. Ethanol is C2H5OH. Can you calculate percentage of carbon? Yes. What will be percentage of carbon? Sir, weight of carbon upon total weight into 100. What is weight of carbon? Sir, I have 2 atoms of carbon, so 2 into 12, 24. Molecular mass, 46 into 100. Into divide. Percentage of oxygen, sir, I have 1 oxygen, so 16 into 1 upon molar mass into 100, sir, percentage of oxygen. Because it is containing only 3 elements, so either you do it for hydrogen, or 100 minus this and this will give you percentage of hydrogen also, which you can also calculate using the same pattern. Weight of hydrogen upon total weight. Why you should know this? Because in some questions beta, you have to check this common sense and apply it to come up with an answer. I'll give you a reason why. I'll give you a example why. Attempt this one. This is also a JEE Mains 2024 question. If you try to do this question using the traditional empirical and molecular formula determination method, you will fail, because the integer is coming out to be a fraction. It will be 11.5. You can devote that time, and obviously with these lecture notes you should devote that time, but you will not be getting answer. Then sir, how shall we do such questions? Beta, in such cases you have to do option elimination only. Like it is telling you that these are the molecular formula, and having carbon this much percent, hydrogen this much percent, and obviously remainder is oxygen, as in 100 minus this plus this will be the percentage of oxygen. Don't invest that much of time. Use option elimination. How, sir? Percentage of carbon given is 42.1. I've told you that percentage composition. So this will be weight of carbon upon weight of organic compounds. A molar mass of the compound is given 342 into 100. So can you calculate weight of carbon? Yes, sir. Weight of carbon will be 42.1 into 342 upon 100, that means 3.42. Weight of carbon is, sir, 12 gram is for one atom, and this will be number of carbon atoms. So can you calculate number of carbon atom? Yes, sir. Just do this. This multiply, this much into divide you have to do. You will be getting the number of carbon present in the molecular formula. And once you check it, this is C12, this is C12. You will be getting this as 12. So ultimately you have eliminated two options. You are getting your answer. Now after that you should do it for either oxygen. So oxygen, how to calculate? Sir, 100 minus 42.1 plus 6.4. This will be percentage of oxygen. And percentage oxygen you can similarly equate. But yes, sir, that means that we do not have to make that table. No. In some questions, whenever every option is given, rather this should be a more probable, this should be a most probable trick for you to come up with an answer. No, sir, I don't want to apply the trick. I will do the traditional method. Traditional method you should know, but make sure you do that traditional method in this question, but back at home. Sir, what is the traditional method? I'm telling you that also, but you will not be getting answer with the traditional method few times. So for that you have to use some common sense, and that common sense you should only know, you can only know once you know what is actually is percentage composition. I hope everybody is clear. So answer for this question is definitely D. Now, sir, what is the traditional method? Yes, traditional method is also very famous. So let me come to the traditional method. Now, empirical and molecular formula determination. Again, a very probable concept for your NEET examination. What is it? Sir, first of all, you should know what is molecular formula, what is empirical formula. Sir, molecular formula is formula giving exact number of atoms. Empirical formula is a formula which is giving you the number of atoms in a simplest ratio form. Like for example, for carbon dioxide, molecular formula is CO2. Ratio is 1:2. Can 1:2 further be simplified? No. So empirical formula is also 1:2. So molecular formula and empirical formula can be same also. For methane it is CH4, empirical is also CH4. For benzene this is C6H6, but 6:6 can be simplified as 1:1. So empirical formula is not equal. Obviously it can be equal, it cannot be equal. So simplest is CH, molecular is this much. Similarly for heptane, I hope you understood it. Sir, then how to calculate molecular formula? Beta, molecular formula is always some integral times of empirical formula. And how to calculate this integer? This n dash, some molecular formula mass as in molar mass upon empirical formula mass upon empirical formula mass. Sir, how to calculate, how to estimate this empirical formula? Let us, now this is obviously a step-by-step mathematical approach. You should, like for example, you will be given such questions in your examination: percentage of carbon, hydrogen, nitrogen. Now, if you add these percentages, it is not 100%. So definitely the fourth element will be, in the question it will be given, it is given oxygen, but the percentage is not given. So how to calculate that percentage? 100 minus all summation of all these, which is this. After getting their percentages, calculate the mole ratio. How to calculate mole ratio, sir? Beta, treat this as the weight. So weight upon atomic mass. For hydrogen, weight upon atomic mass. For nitrogen, weight, given percentage is your weight upon atomic mass, which is 14. For oxygen, weight, which is 26.63 upon atomic mass, which is 16. Yes, these are also some questions which will take a bit of your time. So make sure you're attempting them in your second go, not in the first one. Now, after doing this, you actually have to calculate the ratio. So obviously you can do that practically while solving. I am just doing an approximation over here. So if it is 12, then this will approximately be 12, 6. If you add 6, it is 1.5 times. So if it is 18, it is 1.5. So this is more than 18. So this is approximately 1.5 or maybe 1.6. What about this? So this is exactly 67. What about this? So 14, 2 is 28. Then 28, 42. 3 times, sir, more than 3 times, approximately 3 point something. What about this? Actually, for such questions, beta, you have to calculate religiously. And once you do not calculate religiously, you may get some error in your calculations. So 26, yes, 26 upon 16, sir, 16 plus 8 is somewhere around 24. So this is also somewhere around 1.5. That means these are the smallest values. So divide with the smallest value, divide everybody. Which is smallest? 1.5. So 1.5 upon 1.5 is approximately 1. 1.5 upon 1.5 is approximately 1. So 67 upon 1.5 as in 3 by 2. 3 point something upon 1.5 is 3 by 2. So this will give you the ratio. Yes, for that you have to calculate. I'm giving you the exact calculation, but yes, you have to be religious with your calculation in these areas, beta. So I hope if you do it, you will be getting 1 over here. I guess this will be 4. This is 6.7. I'm sorry, beta, this is 6.7. I beg your pardon. This is 6.7. Because obviously then 100 will not come. This is 6.7. So this will be coming out as 4. This is coming out as 2. And this is obviously coming out as 1. So what is your empirical formula? So carbon 1, hydrogen 4, nitrogen 2, and oxygen 1. This is my empirical formula. After that, sir, you have to calculate empirical formula mass. So empirical formula mass will be carbon 12 into 1, hydrogen 4, nitrogen 14 into 2, oxygen plus 16. So I guess once you will solve this, the empirical formula mass is coming out to be, has anybody calculated? No. I guess this will be 12 plus 4 is 16, 14 into 2 is 28 and plus 16. So 6 is 12 plus 2, 0, 2, 2, 3, 4, 5 and 6. This is also 60 beta. So empirical formula mass is also 60. Molecular formula is also given out to be 60. So value of N dash will be 1. So here also empirical formula will be equal to molecular formula, which will be equal to C1 H4 N2O. So this will be your answer, and you will be getting such questions in your examination. And mind you, don't attempt these questions in the first 1.5 hours. But yes, after going for your first attempt, you may take 1 hour 45 minutes beta, but still you will be left with 1 hour 15 minutes. And in that 1 hour 15 minutes, actually that will be making a difference between you will be getting choosy and doing these extra questions, which will be creating an edge between you and the other aspirants. So if you are not planning things properly, then also learning will not help you so much, because you have to be an efficient time managers also. As great doctors going down in your professional career, you obviously have to manage that time beta, prioritize your job, and then you will be good at doing anything. So this is the reason NTA is testing you with all those. Yes, NTA is not a credible organization now these days. You can obviously feel the same, but still, instead of criticizing, let us say whatever is the procedure, not give it any IUPAC, any nomenclature, whatever is the procedure. The procedure is good because it is filtering people who are efficient are actually getting ahead. If at all such mishappenings are not taking place. So I hope everybody is in sync with this. Chalo. What time will be the class? Beta, I'll be taking time because I want to justify all of the students who are maybe listening to this. Maybe they are getting somewhere around 200, 300. Even I want to help them also. So if you are sitting here already having 600 marks, then obviously you can attempt these questions and practice hard. But for the remaining number of students, the 21 lakh students, which will definitely be enjoying this. So if you are not enjoying beta, then you are not serious. So please be serious for yourself and definitely it will be helping you like anything. Chalo, moving forward. Now, sir, all the time that thing gives you the answer? No. Sometimes the simplest ratio do not give you an integer. Sir, at that point, what shall we do? Like for example, you are having a metal oxide with 70% metal. That means your oxygen will be remainder 30%. First, calculate mole ratio. Molar mass of metal is given. It is 56. So, sir, 70 upon 56. Oxygen is 30 upon 16. Now here, why I told you should do calculations properly. Although I have done it with an average. But yes, I am not giving a NEET examination. I am telling you how to give your NEET examination. So here I am being quite serious about the calculation because beta, this will definitely make huge error in your answer. So if you calculate till 2 place of decimal, this is 1.25 and 30 by 16 is 1.875. Now I am being specific. How? So which is lesser? 1.25. So 1.25 upon 1.25 will be 1 definitely. But beta, 1.875 upon 1.25, you cannot even write it as 1. You cannot even write it as 2. Once you will solve it, you will definitely see you can only write 1.5. Just let me also do it. 1.5 or 1.25. Let me check. 1.5. That means that this is 3 by 2. So sometimes even simple ratio will not land you with an integer. Then in such cases, what shall we do? Think of your common sense. I've already converted 1.5 in a fraction, 3 by 2, an integer 1. Now 1 is to 3 by 2. What shall I do to make it an integer? The denominator is 2. So multiply by 2. So 1 into 2 will be 2. 3 by 2 into 2 will be 3. So I have used that denominator and multiplied. This has given me a simplest ratio, which is 2:3. So empirical formula will be M2O3. If you calculate the empirical formula mass, it will be coming out 160. That means here also N dash will be 1. That means this is empirical formula also, and this is molecular formula also. So this thing also you should know. Yes, it will require much of your mathematical skills, but beta, most of the time it is asked from a NEET aspirant that whether you are having that spontaneity, and spontaneity requires mathematics. So please at least practice such numericals so that you are not facing any issues while your D-Day. I hope everybody is clear with this as well. Now, moving finally to mole concept, last portion, which is concentration terms. So what are these concentration terms? So for solution chapter also it will be used. Concentration terms are characteristic which defines the number of or the amount of solute which I am using to dissolve in a particular solvent, and then we will be defining loads of concentration characteristics, because we will not all the time write theory that this much gram of that you'll put in this much gram of water or this much gram of solvent. So rather, we in the reagent bottle we apply stickers, and that stickers has a definition, and those definitions are concentration terms which are characteristic of any solution. Like we are characterized by our names, our father name. Maybe two people can have same name, but they will definitely have different father's name or different places of origin. So these are our characteristics. So what are characteristic of solution? Let us work on that. Now, for ease of your mathematical calculations also, beta, you should always do this. What I will be doing is, whenever I will be talking of solvent, I will be marking it as 1. Mass of solvent W1, volume of solvent V1. Whenever I will be talking of solute, I'll be marking it as 2 in my formula, so that the derivation, whatever the formula also you should learn, you should always keep in mind, because some certain formulas you have to derive on the D-Day. Yes, for a NEET examination you should not do, you should learn those conclusions, but still to learn those calculations, the conclusions, I will be mentioning solvent as 1, solute as 2, and whenever we are talking of solution, I'll be just writing solution. So this is ground rule number 1. Now, what are the concentration terms? The very famous one is mass by mass percentage. What is the definition? Characteristic of a solution is defined by the solute. Therefore, we are always focused on solute with respect to solution. So by mass percentage will be mass of solute, so W2, upon mass of total, which is solution, into 100. Volume by volume percentage will be volume of solute upon volume of solution into 100. Sir, because they are ratios, so if I'm putting mass in gram, so this should also be in gram. If this in kg, so this is also in kg. So I'm not mentioning the unit, because obviously you will try to match it. You will keep the units same. But yes, sometimes mass by volume is also defined. Then you should learn the definition. This is weight of solute in gram. Please remember this, students miss this, upon volume of solution, but in ml, into 100 will be giving you mass by volume percentage of that particular solution. I hope it is clear. Moving to next one. If I do not multiply by 100, so 100 is percentage. If I multiply the same by 10 raised to the power 6, so 10 raised to the power 6 is 1 million. 1 million is 10 lakh. So if a solution is very, very dilute, that means even smallest amount of solute is impacting that solution. For example, I have a factory and I belong to an environmental ministry, and I want to check whether that factory is polluting the ponds and water body around it. Then even small fraction of fluorine or those toxic elements present in 10 lakh sample of solution can be hazardous to human life. That's why for such dilute solutions also, what concentration term is generally preferred? Parts per million or even parts per billion. So billion will be 10 to the power 9, but yes, for NEET examination it is not generally asked, so I'm only giving you for parts per million. Moving forward, chalo. Next, sir, mole fraction. What is mole fraction? Sir, mole fraction is fraction of any component upon total moles. So mole fraction of solute will be equal to number of moles of solute upon total moles. Total moles is solvent plus solute. Mole fraction of solvent will be number of moles of solvent upon total moles, which is N1 plus N2. So for a binary solution, if you add mole fraction of both the components, it will always be 1. Most of the student forget this during examination. If mole fraction of first component is given, then mole fraction of other component will be 1 minus the other component for a binary solution. And for our syllabus, even advanced asks most of the time questions for binary solutions only. So I hope everybody is clear with that also. Chalo. Pathak ji is saying, sir, I'm getting 690 and 116 chemistry. What should I do to improve chemistry? Beta, be with me for all the chemistry lectures, and definitely it will be helping you like anything. But yes, learn and practice. Learn and practice. The more you practice, the more you are going to get your marks enhanced and amplified. Okay, Arth? Chalo beta. Now, moving forward. Sir, what is strength? Strength is defined as weight of solute in gram present in 1 liter of solution. So denominator is volume of solution in liter. This is strength. So unit of strength will be gram per liter. I hope everybody is clear. Now, next is, sir, if in the numerator you do not use weight of solute, rather you use number of moles of solute, so 2 upon volume of solution in liters, then this will give you molarity, which we generally write as capital M. Obviously, you can calculate this number of moles of solute because most of the time weight of solute is given in gram upon molar mass of solute, because solutes are 2 into weight of solution. Sometimes it is given in ml. So, but by theory you have to, by definition you have to put in liter. So divide by 1000, that 1000 will come in the numerator. So this defines the very famous concentration term, which is molarity. Moving forward, what is molality? Molality we define as small m, which is again number of moles of solute, but not volume but weight, not of solution but of solvent. So weight of solvent, and definition says it should be in kg. You can again convert it, weight of solute in gram upon molar mass of solute, weight of solvent if placed in grams, or 1000 will come in the numerator. Now, a very important, obviously, unit of molarity, capital M, is moles per liter. Unit of molality, small m, is moles per kg. One very important point, whenever you have a concentration term which is having volume factor, so beta, volume changes with temperature. If you increase temperature, volume will increase. If you decrease temperature, volume will be decreased. So with temperature change, volume change, and therefore concentration term will also change. So practically speaking, you will not use such concentration terms to label your reagent bottles. Rather, you will use that concentration term which is practically indifferent from temperature change, which is all the concentration terms which are just having weight factor. So among molarity, capital M, and molality, small m is considered a better concentration term because it do not changes with temperature. That is written over here also, a very famous point. But as I promised, I am touching everything through from basic. Chalo. Now, very important conclusion, beta. Interrelation between concentration terms. I am with this formula, beta, I can give you 10, 20, 25 questions of your examination, JEE, NEET, more than 25. So instead of giving you that questions, you can let us revise the formula and derive it also. Why? Because the derivation will help us retain this formula for a longer duration, at least till 21st of June. So if you are given molarity of a solution, percentage is weight by weight percentage, density of solution, D represents density of solution, but the unit should always be gram per ml. This is 10, and M2 is, obviously we have defined it 2 as in for solute. So this is the relationship between all these concentration terms. In your question, what is done? Any one of the concentration term is hidden and others are given. So just the task is to do the mathematics. But for us, the task is to let us derive it, so that you will not be deriving it in the D-Day. You should learn this and directly apply the formula. Sir, let's say if I'm having, like, for example, let us do this with a question. Let's say, calculate the concentration of nitric acid. So, sir, this is my solute. In moles per liter, that means concentration in moles per liter, as in molarity is asked, which has a density of this much. So this is density of solution, so small d, unit is gram per ml, and mass percent of nitric acid, mass percent as in weight of solute upon weight of solution, is given out to be 69 upon 100. So because this weight of solute upon weight of solution into 100 is the percentage. So this is my value of percentage. Now let us formulate the formula so that we revise it for a longer duration of time. So ultimately, we have to calculate molarity. Molarity is defined as what? Number of moles of solute upon volume of solution in liters. Let's say this volume given is in ml, so I divide it by 1,000. Now, what is number of moles of solute? So number of moles of solute is weight of solute in gram upon molar mass of solute. I hope you can calculate, you can formulate this number of moles formula into, instead of volume of solution, what I'm doing is, sir, mass equals volume into density. So volume will be equal to mass upon density. So mass of solution upon density, that means that density will come in the numerator. This 1,000 is already waiting for us. Now you can obviously see, sir, weight of solute, weight of solute, weight of solution, weight of solution. But I need 100, so take that 100. Will it be replaced by the percentage? Exactly the value given? Yes, sir. So let me formulate this. So all the pink bubbles will be replaced by this percentage into, so this density of solution is pending. This density should be in what unit? So gram per ml. So see, gram per ml. Whatever data D is given in gram per ml, you will directly import that data into 10 upon what else is remaining, some molar mass of solute. This will be the molarity. I hope, I just hope you try and learn this formula. Yeah, perfect, 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 Earth, perfect, perfect. Chalo, great. Now, answer is also, Earth is giving us answer also. So if you solve this, this will be 15.44. Moving to the next one. Now, again, a very important interrelation between concentration terms. Again, a very important interrelation between concentration terms. Interrelation between density of the solution in gram per ml, molarity capital M, molality small m, molar mass of solute M2 upon 1,000. Sir, first thing is you should learn this formula. Sir, it is very difficult for me to learn the formula. So rather, how I am helping you, let us derive it so that after derivation, you start at least getting in sync with the formula. Then it helps you to remember it for a longer duration of time. So this is what I'm trying to do over here. Chalo. So finally, what I need is relationship. So let us first again revise what is molarity. Sir, weight of solute upon molar mass of solute. Why I'm writing like this? Because ultimately I know I have to convert everything. So number of moles of solute into volume of solution, but volume I'll not write. Why? Because again I have to relate with density. So mass equals volume into density. So volume equals mass of solution upon density. So that density will come here, and 1,000 will also come here because this density is in gram per ml. So ultimately I have this D. Ultimately I have this D. So this D will be equal to what? Or else you can either do this not at this stage, or else you can do in this stage also. D is equal to, I have this D, I have this capital M. What else? Sir, I need D, I need capital M. So I have this D, I have this capital M. Rest, bring everything on the other side. So it will be M2 as in molar mass of solute. Weight of solution is, sir, weight of solvent plus weight of solute. So instead of weight of solution, I'm writing this upon 1,000 into weight of solute. So I hope I have this much. Now I need molality also. So let us define molality. Sir, what is molality? Molality is equal to weight of solute upon molar mass of solute into weight of solvent. If this is in gram, then I need 1,000. So can I see 1 upon m? That is the value of m. Just I'm using this with another pen. Sir, small d I have. So shout out inside your room so that you can remember this for a longer duration. Small d is equal to capital M. Now I have a plus, so I need that plus over here, that formulation. So sir, it will be M2 into W1 upon 1,000 into W2 plus this plus, then M2 into W2 upon 1000 into W2. This is simply gone, sir. This we are visualizing clearly. So this is M2 upon 1000. That is M2 upon 1000. What I just need over here, so this thing should be 1 upon M. Just check 1 upon as in reverse. So M2 into W1, M2 into W1, W2000, W2000. So this small d is nothing but capital M, 1 upon small m plus M2 upon 1000. Beta, please, please, please shout out inside your room so that you remember these conclusions. Very, very important. Very, very important. I hope everybody is clear. Chalo. Perfect. Perfect. Now, moving to next concentration term, which is normality. Now, how shall we define this normality and why should we know this normality? Because of the fact that once you write a balanced reaction, then only you can do stoichiometry. With this, I'm moving to the other side of physical chemistry, which is redox reaction. So with this concentration term, I'm getting inside the topic, inside the chapter of redox reaction. So for a redox reaction, what you should know, sir, for a redox reaction, sometimes we do not even require the balanced reaction. Why? Because balancing of a redox reaction is again a task. So for doing some questions where amount of one species and another species are compared, writing the complete balanced reaction sometimes is not even required in the question. Rather, what we should do, we should know this concentration term. Why? Because this deals with the chemical property of the substances, whether it is getting oxidized or reduced. And for that mathematical benefit, we define this concentration term, which is normality, which is nothing but ratio of number of gram equivalent of solute upon volume of solution. The number of moles we know, number of gram equivalent we do not know. So let us define number of gram equivalent. Number of gram equivalent is nothing but weight of solute upon equivalent weight. So now we do not know equivalent weight. So equivalent weight of solute is equal to molecular weight of solute upon valency factor. So now we do not know valency factor. Let us suppose I will tell you how to calculate valency factor. So let us combine the complete formula and know and formulate the basic formula of normality. So basic formula of normality will become weight of solute upon molecular weight of solute, that this is number of moles, into volume of solution in liters. The only thing that will be remaining over here is this valency factor, which will be coming out in the numerator. Sometimes some references write this valency factor as n factor. I do not love it. I do not write it. Why? Because we generally take n as number of moles. So I do not write n factor. I write valency factor VA. So this is number of moles of solute. So normality will be number of moles of solute into valency factor upon volume of solution in liters. So this is nothing but molarity. Yes. That means normality is nothing but molarity into valency factor. Very important conclusion. Also, number of gram equivalent of solute is nothing but number of moles into valency factor. So these are some important conclusions that you should remember, sir. But still you have not told us what is valency factor. So let us, my slides have ended actually after after the uncertainty of your NEET examination, the RE-NEET. Even whenever I take more than 100 slides, so my teaching panel also gets hanged. So what we do over here is I just bring another slide, another 50 pages. I guess I'll be taking another 1.5 hours to complete redox reaction, where I'll be discussing valency factor completely, and then we'll be knowing how to calculate normality. It will also be helping with some basic questions of ionic equilibrium. So we'll be doing everything in this lecture only, but let me just extract these lecture notes, add that another slide. It will also give us some breathing space to have 2 roti. So I guess this is 10:07 na? Ha. So beta, we are taking, let us take a break, because I also Need to change the slide. So we are taking a break. This is 10:07. So 10:07, 17. Let us meet at 10:20. Please, please, please come back at 10:20. Uh, by the time I just change this slide, and then we'll be coming back. So everybody, please do join. Just eat 2 rotis and come back. We'll be meeting at 10:20. Okay. So taking a break for now. है ना? 10:20 we'll be meeting. Bye bye. Yes, guys. So I'm sorry. I guess nahi. Sir has not gone anywhere. Okay, beta. So hello, welcome back. Welcome back. Let us continue the job which we have set for today. Now, uh, chalo, perfect. So let us finish the job for today that we have set, which is completing redox, because that redox will be helping us to attempt inorganic also perfectly. So nahi. So sir is back, and I am really much amazed and motivated by seeing that. Yes, I'm sorry, I said 10:20, and I guess I got delayed by 3 minutes. So let's start again, beta. Okay, so Mr. Yadav is back. Earth has been performing in the first session. I guess we started around 8. Until that point of time, Earth, Mr. Pathak has been really good. He has been answering all the questions correctly. So yes, now Robin is also here. Chalo beta. Perfect. Acha. Praveen. Parveen is also here. Chalo, perfect. So let us start with redox beta. Now, what we have started discussing redox with the concept of normality. Now, for normality, we know it is molarity into valency factor. Now, what is this valency factor? Valency factor calculation will definitely be helping you to enhance your marks for your NEET examination beta. So let us know how to calculate this valency factor. So calculation of valency factor for an acid. Suppose you have an acid. So for an acid, the number of H plus ion that one molecule of acid is furnishing once it is getting reaction. Once a acid is getting reacted, then the number of H plus ion at that point of reaction it is releasing. HCl can furnish 1 H plus ion, so its valency factor will be 1. H2SO4 can do it for 2. Phosphoric acid can release 3, because whatever are the acidic hydrogens are those hydrogens which are connected with electronegative oxygen. So what shall be the structure of phosphoric acid? Sir, because it's an oxo acid, so a P double bond O group will be there. One OH, second OH, and a third OH. So how many replaceable acidic hydrogen beta? 3. What about phosphorus acid? Sir, phosphorus acid is H3PO3. So it has one OH, two OH, but the third H is connected with phosphorus, which makes it not a acidic hydrogen, a reducing hydrogen. So how many hydrogen it can actually furnish once it is dissolved in water? 2. So although the formula is having 3, but its valency factor will be 2. Similarly, for orthoboric acid, H3BO3, sir, it is having 3, but still you have written valency factor 1. Why? Because this boric acid do not even give any of the hydrogen which is connected with electronegative O. But sir, you said acidic hydrogen is all those hydrogens which are connected with electronegative. For a central atom whose octet is not deficient of electron, this boron is a electron deficient species. How, sir? Let us check that. I have given you the proper structures also. So this is phosphoric acid, this is phosphorus acid. Once you talk of boric acid, this boron, which is sp2 hybridized, again giving you inorganic behind it also. So sp2 hybridized as in trigonal planar. So this boron having the empty p orbital, it can be accommodated with electrons from upside also and downside also. So actually it acts as a Lewis acid, except those electrons from what? From water. And water attaches to boron, making it a negative anion, and water is releasing this hydrogen as H plus. So ultimately, when boric acid is supplied in water, how many H plus this one molecule is furnishing? 1. So the valency factor of boric acid will be 1. So for acid, I'm generalizing. For an acid, what is valency factor? Number of replaceable H plus ion. Similarly, for bases, there is no issue, no such inorganic knowledge in general behind bases. So whatever OH they have, they furnish that OH minus ion in water, and that becomes the valency factor for a base. So for NaOH it is 1, for cesium hydroxide, alkali metal hydroxide, so 1, alkaline earth metal 2, aluminium 3. So I hope you know calculation of valency factor for acids and bases. Now for salt. What salt? Those salts which are not performing any redox reaction. So for them, valency factor is the total charge on either ion. Obviously, cationic charge and anionic charge will be same because salt is a neutral species. So here 1 because Na plus or Cl minus 1. So calcium has plus 2 charge. How many calcium? 1. So valency factor is 2. Anion is also chlorine minus 1 but 2. So minus 2. For AlCl3 it will be 3. What about aluminium sulfate, sir? Sir, aluminium has charge plus 3. But how many aluminium? One molecule is having 2. 2 aluminium ions. So total charge will be 6. I hope everybody is clear. Moving to those salts which are now reacting. How reacting, sir? Chemical reaction is transaction of electron. So if I give electron, I'm oxidizing myself. If I gain electron, I'm reducing myself. So for a reaction, for a salt which is undergoing this electronic transaction, as in which is participating in a redox reaction, what is the valency factor? Valency factor is the total number of electron transferred per unit of active ion. For example, the very famous ion, dichromate ion in acidic medium, it acts as a strong oxidizing agent. It will oxidize other and it will reduce itself. It reduces itself to form chromium in +3 oxidation state. So what shall be its valency factor? What is oxidation state of chromium? I do not know. Let's say it is X. So 2 chromium, so 2X. For oxygen, it is -2. How many oxygen? 7. So 7 into 2 is 14. Overall charge is -2. So what shall be the value of X? Sir, +6. That means chromium from +6 oxidation state is going to +3 oxidation state. How many electrons are getting transacted? So 3. Because I was there in +6, I will eat 3 electron. 1, 2, 3 and will reach +3. But sir, this one ion is having 2 chromium. So both the chromium will take 2 electrons, will take 3 electrons. So how many total electrons this one unit is taking? 3 into 2, that is 6. So therefore, valency factor of this dichromate ion will be 6. I hope you know how to do it. So for all these species, normality will be equal to their molarity into the valency factor. So for acid, for bases, for normal salt and for redox transforming salts, this is the way you should know how to calculate valency factor. Now, obviously, I have given these slides for all those students. Ha beta, we'll be wrapping up around 11:30. Vishwanand, है ना? चलो. Now, the reason I've given you these theory is because I know many of the students would wish to just have a read. So oxidation, I have already summarized. Oxidation is basically, sir, oxidation is basically loss of electron. Once you lose electron, your oxidation state will increase. Similarly, reduction is once you gain electron. So this is not loss, I beg your pardon. This is gain. This is gain of electron, and once you gain electron, your oxidation state decreases. Obviously, you know some oxidation reduction definitions also. So this is for all those students who are feeling not efficient about inorganic chemistry. So I've given you theory also, but this is the basic thing that you should know. Whenever oxidation and reduction are happening simultaneously, that is called a redox reaction. Sir, I do not know how to calculate oxidation state. So again, giving you the theoretical problems regarding oxidation state. So those of all who need it, the notes will be given to you. Sir, from where to access these notes? PW NEET English WhatsApp channel. The moment I finish this live, I'll be uploading these notes in the WhatsApp channel. Kindly download these notes through PW NEET English WhatsApp channel, and please attempt these things by yourself too, to just have an overview. Now, how to calculate oxidation state? You have some traditional methods, but I am telling you, in some good questions, you will be failing to get the oxidation number calculation, oxidation state calculation. So I'm giving you common sense first. Now, for example, I have water. So in water, what is oxidation state of oxygen? How to get it? Or all the species? Whenever an atom is making single bond, so contributing How many electrons are participating? 1 1. Here also 1 1. Who is more electronegative? Oxygen. So among oxygen and hydrogen, this will be -1, this will be +1. Among oxygen, this is -1 and this is +1. So what is the total charge on hydrogen? Sir, it is +1. On this one, it is +1. On oxygen, what is the total charge? So -1 as in -2. So this is how you can calculate oxidation state of every covalently bonded atom. I hope everybody got it. Similarly, over here, sir, this is from here, oxygen will get -1. From here also, it will get -1. So, but this bond oxygen is making among themselves. So, who is more electronegative? So, both are same. So, who will withdraw more partial charge? So, no one. So, for this, the contribution will be 0 0. So, what is the overall oxidation state of each oxygen? Sir, it is -1, and such oxygen is known as a peroxide. Now, what is oxidation state of sulfur? Sir, double bond, so contribution is 2 2. So this is also 2, this is also 2 from the two double bonds of sulfur with oxygen. Oxygen is electronegative, so -2. Sulfur is electropositive, so +2. So that means sulfur is getting with oxygen a double bond, so +2. So from down also it will get +2. From left it will get +1. From right it will get +1. So total partial charge will be +6. I hope with the structure you know. Sir, once can you explain example 1 again? Yes, beta. Beta, I'll be just doing that here and will be telling you everything again. है ना? चलो. I'm telling you everything here what I have communicated there. Chlorine, oxygen, this double bond. How many bonds are getting made? 2. So what are the number of electrons involved? 2. So write 2 2 on both the side. The atom which is more electronegative will be -2 and which is less electronegative will be +2. Do this for all the possible bonds. So sir, again 2 2. So oxygen will be -2, chlorine will be +2. From this double third one also, oxygen will be -2, chlorine will be +2. So this is a single bond, so contribution will be 1 1. Oxygen is more electronegative, so this will be -1 and this will be +1. So what is the total charge, total partial charge on chlorine? So 2, 4, 6 and then 7. So for chlorine, the partial oxidation state will be +7. Why I'm saying partial? Because it is the partial charge. Overall, whatever it is, a molecule or ion, that charge is here. This is a charge because this is neutralized between the covalent bond. Because covalent bond is also polar. So the one which is more electronegative will have the partial negativity, and the one which is less electronegative will, or in easier language, electropositive will get the partial positivity. So these are the partial charges and this is how you should calculate it. Chalo. Oh, black mystery. Sir, today J gone well. Black mystery, I'll be coming to the advanced discussion tomorrow. All the very best, beta. I actually knew black mystery. You will be doing great. So we'll be coming live at PWJ English channel tomorrow with the advanced paper discussion. So Black Mystery, proud of you. Guys, this is a student. Ask. Anybody can ask from Black Mystery. We have met, I guess, Black Mystery from October, na? Once we have started with J channel. And this is the level of trust that we have got, that this student of mine has given the paper and is coming to a NEET channel and telling me that his advanced paper is good. So beta, you are the reason. I mean, I cannot tell you what goosebumps I'm getting with just reading that statement that your advanced paper has gone well. So all the very best, beta. Proud of you. Chalo. Nitrogen. Sir, contribution 2 2. Oxygen is more electronegative, so -2. Nitrogen +2. Sir, one bond, contribution 1 1. Oxygen more electronegative, -1, less, so +1. So for nitrogen, the partial charge is +3. So in nitrite ion, NO2 minus, what is the oxidation state on nitrogen? You can calculate it also with the method, the traditional method you know. But this is the exact method which you can only apply if you are good with the chemical bonding, that is the structure formation. So sir, shall we know such structures? Yes, beta. Definitely you should know such structures. है ना? Chalo. Perfect. Moving forward, guys. Now, some other structures, sir, carbon suboxide, some famous examples, beta. Carbon suboxide is C3O2. So C3O2. Now, let us work on the oxidation state of carbon. Sir, here contribution is 2 2. I'm not writing for electronegative. Oxygen will be -2. So from here, carbon will get +2. Sir, because they are similar atoms, so contribution will be 0. Here also it is 0, but this carbon will get minus plus 2 from this side. So this carbon has a overall oxidation state of plus 2, this has a overall oxidation state of plus 2, and this guy has a overall oxidation state of 0. So ultimately I have 3 carbons, 2 of which are in plus 2 oxidation state and 1 is in 0 oxidation state. I hope everybody is perfect with this. Chalo. Now Kerose acid, beta, inorganically, I told you in my beginning of the lecture also, I'll be doing redox covering inorganic knowledge as well, because yes, these are some inorganic block chemistry logics that you should know, helping you with them also. Chalo. What is formula of Kerose acid? Sir, H2SO5. That means H2SO4 getting one more oxygen, so that will be attached as a peroxide linkage. Sir, what is that peroxide linkage? This O bond O. Again, oxidation of state of sulfur will be plus 6. You can obviously calculate now. This is also known as peroxo monosulfuric acid. Now, tetrathionic acid is H2S4O6. So anion will be S4O6 2 minus, as in tetrathionate ion. Now, obviously the structure, sir, because there are 4 ox sulfur, so I will have a sulfur-sulfur linkage. And let me work out on this tetrathionate ion. Let me work out on oxidation state, sir. Plus 2, plus 2, plus 1 and 0. So this sulfur will be in plus 5. I hope now everybody can see it directly. This sulfur is also in plus 5. So sulfur, sulfur 0. So this is in 0. This is in 0. That means I have how many sulfur? 4. What is the total charge of all the 4 sulfur? So plus 5. But how plus 5? 2 of the sulfur, plus 10. Total charge on 4 sulfur. Plus 10, because plus 5 this guy is earning, plus 5 this guy is earning, but these two brothers are earning no charge. So they are in 0 oxidation state, and these two sulfur are in plus 4 oxidation state. I hope everybody is clear with this. Moving to the next one. Now, peroxo disulfuric acid, formula H2S2O8. Peroxo, that means that there is again a peroxide linkage between two sulfuric acids unit. So one H2SO4, another H2SO4, one oxygen removing H plus, and a peroxide linkage is formed between them. Sir, this is also known as Marshall's acid, and in them sulfur, both the sulfur are present in plus 6 oxidation state. It has 2 oxygens which are peroxide. All the other oxygens are oxide, that means oxygen in minus 2 oxidation state. Chalo. It's not like NEET. Chalo, perfect. Now, a very famous compound, CrO5, the beautiful chromium oxide. Here, chromium, what is the oxidation state of chromium over here, beta? From the two double bonded oxygen, chromium attains a plus 2. From this one, plus 1. From this one, plus 1. Again, plus 1 and plus 1. So overall, chromium oxidation state is plus 6. Why? Because out of the 4 oxygen, these 4 oxygens are peroxide, where oxygen is in minus 1. And this oxygen, this double bonded oxygen, is oxide, as in minus 2. So how the charge is getting neutralized? 4 minus from 4 oxygen, 1 minus 2 from this oxide oxygen. So plus 6 minus 6. I hope everybody is clear. Now, beta, Arth, Pathak ji, the reason I'm taking this redox, because see, I want to deliver inorganic also. There was a student who was asking, sir, inorganic. So beta, inorganic, for inorganic chemistry, you should know some facts. So those facts I wanted to bring. Rather, I have less number of questions in my redox part, but yes, I have more of these logics, because beta, they are actually important. If you want, sir, I want more and more question to practice, then whatever we'll be doing in the complete week, on Sundays we'll be coming with only relevant PYQs. Because for the weekdays we have planned, although this is a Sunday, I'm talking for next Sunday, that whatever we'll be doing till Saturday in chemistry, physics, biology, everything, every Sunday classes that we'll be having will be complete 500-600 PYQs. But for those students who want to learn theory also, so the week will also have theory and relevant questions. So I hope you can have that level of compassion, Mr. Pathak. Chalo. Because I do not want to offend you, because you have been a religious student today. So that's why I'm answering, beta. Hai I hope, Pathak ji, it is good. Chalo. Again, Pathak ji, these points are important. So please make note. Please learn them. Chalo. Chalo, perfect. Now, sir, what is hypo? Very famous compound hypo, Na2S2O3. This hypo has sulfur-sulfur bond. One sulfur is having sodium, one oxygen is having sodium. So let us calculate oxidation state of sulfur. So here contribution is 1, 1, but sulfur now is more electronegative. So this is -1, this is +1. This is contribution 0, 0 because sulfur-sulfur bond. So this sulfur is present in -1 oxidation state. What about the sulfur which is in between? So this sulfur, it is having +2 from upside, +2 from downside, plus from right hand side. From this sulfur it is having 0. So what is the overall oxidation state of this sulfur? The green one, so +5. So in hypo Na2S2O3, there are two sulfur. One sulfur is in -1 oxidation state and another sulfur is in +5 oxidation state. If you point blank, if you just close your eyes and try to calculate the oxidation state of sulfur using the basic formula, what you will do? So sodium is +1, so +2. Sulfur I do not know. Let's say oxidation state is X, so 2X. Oxygen is -2, so 2, 3 are 6. Equals, because it's a neutral molecule, so 0. That means 2x will be equal to +4. That means x is equal to +2. Beta, this is the average oxidation state. Average as in, out of the two sulfur, each sulfur is on an average contributing +2. But actual, what is the case? Sir, one sulfur is in +5, another sulfur is in -1. So what is the overall charge? +5, -1, +4. This +4 charge, they have, how many sulfur have got? 2. So obviously average is 2, but none of the sulfur is in +2 oxidation state. A very important point which most of the students misses. Chalo, I hope everybody is good. Now, sir, again a very famous NCRT. Beta, NCRT for your NEET examination is word by word. So again, tetra bromo octaoxide. So bromine, the structure also you should know. And obviously this bromine is having +2, +2, +2. And this will have a 0 contribution. So this is +6. This is also +6. What about this? +2, +2 as in +4. So out of the 3 bromine, 2 are present in +6 oxidation state and 1 is present in +4 oxidation state. I hope everybody is clear with this. Moving to the next one. Now, this I'm skipping because these are the rules, the basic NCRT rules that you should know. Those of who do not know, that's why I have written them for you. Fluorine always make compound in -1 oxidation state. In free state or native state, like these elements have oxidation state 0 because they do not transact any electrons. Metals in their compounds, alkali metal always exist in +1 oxidation state, alkaline +2 and aluminium +3. Hydrogen generally has +1 oxidation state because generally it is most electropositive. But yes, why I'm saying generally, because with metals hydrogen will be -1. So with metal hydride, it will be hydride as an oxidation state of hydrogen will be -1. The algebraic something, whatever the charge the overall molecule or ion is having, do the algebraic sum of oxidation state of all the species, that will be equal to the overall charge. If it is a neutral molecule, it will be 0. If it is a ion, then the whatever the total charge will be equated with the summation of oxidation states. Moving forward. Now, for halogens, generally oxidation state is -1, but only for fluorine it is always -1 because oxygen is more electronegative than chlorine, bromine and iodine, so they can attain a positive oxidation state if they are forming their oxides. Like these here, what will be the oxidation state of chlorine? I hope everybody can solve this. So I'm using the algebraic sum only over here. So this is +1 + x -6 = 0. That means chlorine is in +5. Here, iodine is also in +5. Here, bromine is also in +5. So I hope everybody can see that the halogen can attain a positive oxidation state if they are forming compound with a oxide. Now, a table for all those students who are not at all comfortable with inorganic, please remember these anions. Please remember these cations. Maybe they can crack you, they can make you not attempt a question incorrectly. So the very famous ions which every NEET aspirant should learn word by word. So the famous anions and cations I'm giving to you. Moving forward. Now, some basic calculations of oxidation state. The first one, calculate oxidation state of carbon in ferrous oxalate. Why I'm saying ferrous oxalate? Because I told you should know some ions. What is oxalate? C2O4 2 minus. What is ferrous? Fe plus 2. So this is plus 2 plus 2x minus 4 2 ja 8 equals 0. That means 2x is equal to 6. That means x is equal to plus 3. So carbon's oxidation state is plus 3. Oxidation state of nitrogen in ammonium nitrate. So ammonium also has nitrogen. Nitrate also has nitrogen. So how to calculate it? Separately, this nitrogen will be in what oxidation state? Sir, x plus 4 equals, okay, this molecule, this is not a molecule, this is an ion, so it will be plus 1. So oxidation state of this nitrogen will be minus 3. What about this guy? So let's say x minus 6 equals minus 1. So this nitrogen oxidation state will be plus 5. I hope you can clearly do it. If I have a similar molecule, but the molecule is having cation and anion, and both cation and anion are having nitrogen. So nitrogen is present in cation in different oxidation state and in anion in different oxidation state. Always possible. Chalo. Hydrogen cyanide. Carbon, sir, hydrogen cyanide, better draw its structure. Sir, drawn its structure. So for carbon, contribution 1 1, carbon is more electronegative, so minus 1. Hydrogen will become plus 1, so hydrogen is fixed. Among carbon and nitrogen, so contribution 3 bonds, so 3 3. Nitrogen is more electronegative, so minus 3, carbon is plus 3. What is overall oxidation state of carbon? So plus 3 minus 1, as in this carbon is present in plus 2 oxidation state. I hope everybody is clear. Sir, repeat karna please. Jagriti, what repeat beta? Jagriti, pata nahi. हाँ, chalo chalo. Jagriti beta, see this one you want me to repeat? Chalo again, see I'm making it again. Dekho, whenever you are having bonds, whatever number of bonds it is made, you just write that number. So carbon hydrogen 1 1. Among carbon and hydrogen, who is more electronegative? Carbon. So carbon will be minus 1 and it will be forced to be plus 1 because hydrogen is just forming one bond, so its overall oxidation state is plus 1. So fixed, therefore circled. Here contribution 3 3, nitrogen more electronegative, so minus 3, carbon less, because among those 3 shared cloud, who will withdraw the shared electron cloud? Nitrogen. So carbon will be partially positive, nitrogen will be partially negative. Now plus 3 minus 1 is plus 2. So overall oxidation state of carbon and hydrogen cyanide is plus 2. Is what I'm trying to tell you. Now coming to isocyanide. Nitrogen is definitely minus 3. Coming to isocyanide, sir, contribution 1 1, minus 1 plus 1, so hydrogen is fixed. Now contribution because of the covalent bond. So covalent bond is formed between these two. So contribution 2 2. Nitrogen more electronegative, so minus 2, this is plus 2. Sir, what about coordinate bond? Beta, coordinate bond is specially transfer of these lone pair from nitrogen to carbon. Now you tell me how to assign oxidation state for this lone pair donation. Whenever you donate a lone pair, contribution will be 2 2 because 2 electrons are there. But it will be, sir, the one who is more electronegative will give minus 2, the one who is less electronegative will gain plus 2. But once the donor atom is more electropositive, then you do that. Sir, here donor atom is nitrogen, it is more electronegative, so the donor, okay, I beg your pardon, donor atom should be less. You do that contribution 2 2 when you do that contribution A giving or coordinating, giving a coordinate bond to B, you give contribution 2 2. But once the donor atom is electropositive and the acceptor atom is actually electronegative, so this will be minus 2 and this will be plus 2 because it has given, it has taken. But if the donor atom is electronegative, then the contribution is assigned as 0. Therefore, the overall oxidation state of nitrogen will again be minus 3 and of carbon will be plus 2. I hope everybody get it. I hope everybody got it. Chalo. Now, this is a tricky thing, but yes, if you are going to do good in your examination, then you should know such things. Now, again, a block chemistry logic, bleaching powder. What is bleaching powder? Sir, calcium oxychloride. It is, why it is a mixed salt? Because it is having calcium cation, one cation, but more than one anion. chloride ion and hypochlorite ion. Chloride ion is, you know, Cl minus. Hypochlorite ion is OCl minus. In OCl minus, contribution is 1 1. This is minus 1. Chlorine will be plus 1. So chlorine is present in plus 1 oxidation state. So such compounds, such salts which are having, if the number of cations and anions are not same, it is having one cation and two anions. So such salts are called mixed salts. So you should know them also. Moving forward, NOCl. Sir, for NOCl, you should definitely know how to make its Lewis structure. So this is the Lewis structure, or simply you should know this as well, a very common inorganic knowledge, because generally second period elements are more electronegative. But whenever you see and watch the property of NOCl, it is broken as Cl minus and NO plus. Therefore, obviously, oxidation state of chlorine is minus 1. Sir, what about nitrogen? Contribution is 2, 2. Oxygen is more electronegative, so minus 2. So this is plus 2. So what is overall oxidation state of carbon? Sir, nitrogen is already having a positive charge, a plus 1 charge. So the overall oxidation state of oxygen is definitely minus 2. But because of this plus 1 charge, plus 2 it has got from the covalent bond, plus 1 it is already having. So for nitrogen, the overall oxidation state will be plus 3. I hope you are getting this point. Hello? Chalo. Moving forward. Now, for coordination complexes, you already know, you should know the charge on the ligand. So let's say cobalt cyanide complex. So oxidation state of cobalt, I do not know, X. Cyanide is a negatively charged ligand with charge of minus 1. So 6 chlorine having minus 1, 6 cyanide ion ligands having minus 1 charge, so minus 6 equals minus 3. So cobalt will be present in. See, with the redox part, I have discussed so many inorganic logic that obviously that's why I am requiring much of time to discuss all these. But beta, please go through these notes once the class is done. It will be helping you like anything. Moving forward. Now, sir, redox reaction can be of various types. So it can be a combination reaction where magnesium going from 0 to plus 2, that means oxidation, because increase of oxidation state. Nitrogen going from 0 to minus 3, that means decrease, so reduction. But how this oxidation reduction is happening? When these are combining. Redox can also be decomposition. Potassium chlorate is getting decomposed, forming KCnO2, a very famous reaction for the production of oxygen, a block chemistry logic. Again, an example of redox. What type of redox? Decomposition. Why? From plus 5 to minus 1, as in oxidation state is decreasing, so reduction. From minus 2 to 0, so oxidation. So oxidation reduction on a decomposition reaction, a very famous inorganic reaction. I hope you are learning this also. Sir, the electrochemistry logic, more reactive metal can displace the less reactive metal. How? Because they are having less electrode potential. So copper, zinc, more electropositive, reacting with copper sulfate, copper getting reduced, zinc getting oxidized, because electrode potential of copper, reduction of copper is electrode potential, as in reduction potential of copper is higher. So that decides your electrochemical series also, electrochemistry logic also. And again, an example of redox reaction. What type of redox? Displacement. This displacement is done by a metal, so metal displacement. Sometimes metal react with water, then will form corresponding hydroxide. So this will be again a displacement, but who is displacing? Non-metal. So again, an example of non-metal displacement reaction, again a redox reaction, because potassium from 0 is getting to plus 1. This is oxidation. Who is getting reduced? Hydrogen from plus 1 to 0 oxidation state, so hydrogen is getting reduced. I hope inorganic logic, you have to make yourself comfortable. How to make yourself comfortable? Beta, read. So you obviously have to read. Chalo. Last and most important, disproportionation. Again a redox reaction, but one element in a compound, one element and the same element will undergo oxidation also. The same element will go reduction also. So oxygen in minus 1 oxidation state is getting oxidized to form O2 gas. Oxygen in minus 1 oxidation state present in hydrogen peroxide is getting reduced to water. Inorganically, a very famous point, H2O2 hydrogen peroxide is not a stable compound. It decomposes. Now we know it's a disproportionation redox reaction. It decomposes and stabilizes itself to what? Water and oxygen gas. I hope everybody is clear with this. Moving forward. Now, this I have already told you that the stoichiometry we have already learned. So if you want to do the mole concept in a balanced reaction, you have to balance the reaction. How to equate the moles? Number of moles of A reacted upon stoichiometric coefficient of A will be equal to number of moles of B reacted upon stoichiometric coefficient of B will be equal to number of moles of C produced upon stoichiometric coefficient of C will be equal to number of moles of D produced upon stoichiometric coefficient. These are called moles of reaction, by which you compare moles. Through stoichiometry, we know this. We have already done this, although this is how you relate moles of a reaction. But sir, if a question is given where balancing is itself a job, then what shall we do? Do not calculate moles, rather calculate number of gram equivalent, because that number of gram equivalent gives you law of equivalence, which says irrespective of whatever amount, whatever moles of U is required, number of gram equivalents are always equal. Why? Because they incorporate, they hide valency factor within themselves. So whenever you have a chemical reaction, their number of moles may be equal, may not be equal, but one thing will always be equal, that is number of gram equivalent. So whenever you have a chemical reaction, be it whatever it is, number of gram equivalent of A reacted will be equal to number of gram equivalent of B reacted will be equal to number of gram equivalent of C produced will be equal to number of gram equivalent of D produced. If I have some more reactant over here, if I have some more product over here, be it, because we do not have to balance. We are just learning this, that number of moles can only be equated once you balance the reaction, but number of gram equivalents are always equal because they incorporate valency factor within themselves. We can definitely calculate their valency factor. How? Those four things I have already told you. I hope everybody in sync with this. Sir, how to calculate number of gram equivalent? We have already done that in normality. Let me summarize it for you. Number of gram equivalent can also be calculated as weight upon equivalent weight. It can also be calculated as moles into valency factor. It can also be calculated as normality into volume. It can also be calculated as normality is nothing but molarity into valency factor into volume. Now, these are the ways you can equate number of gram equivalent. Moving forward. Now, sir, but here you have given one more thing. Sir, equivalent weight. What is equivalent weight? We have already learnt it. Equivalent weight is nothing but molecular weight upon valency factor. So this is how you should know how to calculate equivalent weight also. Molecular weight upon valency factor. What is valency factor? So that we know. But for certain compounds, now this is a D block logic. So I'm coupling everything, summing and summarizing everything for you. A very important inorganic knowledge I'm placing over here. What? Potassium permanganate is KMnO4. Sir, it is also a strong oxidizing agent like K2Cr2O7. But K2Cr2O7 is a strong oxidizing agent only in acidic medium. KMnO4 is a strong oxidizing agent in all the medium. Acidic, basic and even neutral. It oxidizes others and reduces itself. But it reduces itself to what form depend upon the medium. In acidic medium, it reduces itself to Mn+2. In basic or not basic, neutral or very mild basic, it reduces itself to MnO2 manganese dioxide. In strongly basic medium, it reduces itself to manganate ion, which is MnO4 2 minus. Manganate ion is MnO4 minus. So valency factor from here in acidic medium will be +7 to +2 as in 5. In neutral from +7 to +4 it is 3, and in basic from +7 to +6 it is 1. So that means we have to learn this, not learn beta. This is very, very important. Another D block logic. So with these topics, I am summing inorganic as well for you. So I hope you are getting what I am saying. Moving next. Sir, then if you have told us how to calculate valency factor, equivalent weight, let us calculate equivalent weight. So for example, if one of your compound is ferrous oxalate is FeC2O4. Sir, ferrous oxalate will do what redox? Ferrous ion will form ferric ion. Oxalate ion will form CO2. Now, if you know this inorganic knowledge, then one molecule of ferrous oxalate is transacting how many electrons? So from +2 to +3 transaction is 1 electron. And what transaction? Sir, because it is oxidation, so this is loss. So this is losing 1 electron. Carbon from +3 oxidation state is going to +4 oxidation state. So carbon is losing, one carbon is losing 1 electron, but this oxalate ion is having 2 carbons, so it will be into 2. So again, loss of 2 electrons. So this one molecule of ferrous oxalate is losing how many electron in total? 1 by ferrous ion and 2 by carbon of oxalate ion. So what is the total number of electrons lost? So 3 by 1 molecule. So its valency factor will be, so if you are supposed to calculate its equivalent weight of this will be its molecular weight upon 3. I hope you are getting it. Moving forward. For hypo, again an inorganic knowledge. Hypo is S2O3 2-. In acidic medium, it converts itself into S4O6 2-. S2O3 2- converts itself to S4O6 2-. Oxidation state, sir, it was different, na? It was -1 +5, no matter. Why? Because I am doing the average only. Here, oxidation state of sulfur is, sir, 2x. We definitely know, we have already done it. So +5 minus 1 is a +4 by 2, so it will +2. And here, so 4x minus 6 2 are 12 equals -2. So 4x is 10, so x is 2.5. That means how many electrons are transacted per sulfur? 0.5. But how many sulfur? I have 2. So number of electron transfer is half into 2 as in 1. So valency factor will be 1 in acidic medium. In basic medium, S2O3 2- is converting into sulfate ion, where oxidation state of sulfur is +6. So from +2 to +6 as in, sir, 4 electron transacted per sulfur. So for 2 sulfurs, sir, 8 electrons. So valency factor will be 8. So for this similar species, for hypo, valency factor will be 1 in acidic medium, will be 8 in basic medium. I hope inorganic knowledge you are taking with yourself. I know most of you will be not comfortable beta, but again, the block chemistry, although that block chemistry is removed from what? From NCERT syllabus. But NEET is definitely going to ask you, because it's a RE-NEET, it is definitely going to ask you some of these NCERT block chemistry logic as well using redox kinetics. Chalo. Last is, sir, what is intramolecular redox? Beta, sometimes one species give electron, another species gain electrons. If one molecule is having 2 species in which one ion is getting oxidized and another ion is getting reduced, then this becomes a redox which is taking place within the molecule, hence termed as intramolecular redox reaction. So like ammonium, again an inorganic knowledge also. Ammonium nitrite on thermal decomposition produces nitrogen gas and water. Again, a very famous reaction for production of nitrogen, block chemistry logic. Now nitrogen here is in, we have already calculated this. Nitrogen is -3 oxidation state, and in NO2 minus x -4 equals -1, so this will be +3. So nitrogen from -3 to 0. So this is increase of oxidation state. That means this is oxidation. And from, acha, not +3, na, +5 I guess. Because x -4 equals -1. Sorry, +5. And nitrogen from +5 to 0, sir, it is a reduction. How many electrons are getting transacted? +5 or +3. Let us do it. NO2 minus x -4 equals -1. X equals, acha, this is +3. I'm sorry. Initially I've written right. So this is +3. So +3 to 0 and -3 to 0. But now you will not add. Why? Because what is the transaction? I have given 3, you have taken 3. So transaction is of 3, no? Sir, but here you added, because beta, both the ions were doing the same job. So here I have to add those electrons, because this one unit as a whole is giving 3 electrons. this one unit as a whole, this is giving and another one is taking. I mean, this is getting reduced, so this is taking, this is getting oxidized, so this is giving. But what is the transaction? So 3. So here valency factor will be 3 only. It will not be getting added. So for ammonium nitrate, equivalent weight will be molecular weight upon 3, not 6. But for ferrous oxidate, it will be molecular weight upon valency factor, which is not 1 or 2, it is 3. You have to add. But here I'm not adding 3, 3. I hope you're getting the point, because here the same thing is happening. Here they are transacting 3 electrons. So I will not count 3 2 times. No, 3 I have given, you have taken. So transaction is 3 only. I hope everybody is clear with this. Chalo. Now, chalo. Next is equivalent weight of valency factor of some species. Now we have already defined it, but sir, why you are again telling us this? Because if somebody is doing a disproportionation reaction, if some species is involving in a disproportionation reaction, then the valency factor, then the equivalent weight is calculated as equivalent weight is equal to molecular mass upon N1 plus molecular mass upon N2. And what is this N1 and N2? We definitely know for a disproportionation reaction, 1/2 will be oxidation half and 1/2 will be reduction half. So whatever is the electron transacted in each half becomes the value of N1 and N2. You do not add them, you do not leave any. You take their LCM as in M upon N1 plus M upon N2. Sir, how do we know this? Beta, this is a statistical formula. So there is no derivation. This is a statistical observation which has given us this formulation that for a disproportionating species, equivalent weight is calculated as molar mass upon first transaction plus molar mass upon second transaction. Now let us do that transaction over here. So bromine from 0 is converting to -1. So from 0 to -1, transaction is of 1 electron, but this one molecule is having how many atoms? 2. So this is 2. So N1 value will be 2 in this particular case. What is N2? So from 0, x minus 6 equals -1, that is, it is +5. So from 0, it is getting to +5. So 2 will be transacting 5 into 2 electrons. So this value is 10. So equivalent weight will be the LCM, m by 2 plus m by 10. So once you will solve this, this is 20, this is 10 plus 2 as in 12m. So this is m upon 20 by 12. So what is 20 by 12? 4 5 ja, 4 3 ja. So this is 5 by 3. So its valency factor is actually 5 by 3. How we have got it? First, we have seen this statistically, and then we have formulated that it will be molar mass upon N1 plus molar mass upon N2, where N1 and N2 are the electron transacted in the two different half of the reactions. Again, you can use the same logic for any such type of questions which will ask you equivalent weight. Like for example, equivalent weight of a metal oxide will be equal to equivalent weight of metal plus equivalent weight of oxide. Why? You do not have to worry about what is the valency factor, because equivalent will have that valency factor within itself. Sir, how it is going to help you? Like for example, you are given that X gram of metal is reacting with Y gram of chlorine, and you are forming a metal chloride. Let's say in that question you are asked how to calculate equivalent weight of metal. How to do it? Sir, you know number of moles can be equal or not, but number of gram equivalents are always equal. So you will say number of gram equivalent of U will be equal to number of gram equivalent of U. And for number of gram equivalent, what formula we will use? Weight upon equivalent weight. So weight of metal is X. Equivalent weight of metal is E. I do not know. Let us find it. X will be given to you in the question, will be equal to, sir, number of gram equivalent of chlorine. Number of gram equivalent of chlorine will be weight of chlorine, that is given in the question, upon equivalent weight of chlorine. Now equivalent of chlorine you can calculate. How? Chlorine is going from Cl2 to chloride as in -1. That is from 0 to -1. Transaction is of 1 electron. So this one molecule is having 2 chlorine, so it will be into 2. So for this chlorine, equivalent weight will be what? 35.5 into 2, which is molecular weight, upon valency factor, which is again 2. So equivalent weight is 35.5. That I have directly used over here, because for such species you know the trick now. So the weight will be given, you can directly calculate equivalent weight. Similarly, if it is given for an oxide, then do it. Sir, how to calculate valency factor for an oxide? In a similar manner, because oxygen from O2 is converting to O2 minus. Do that valency factor thing. So you will be getting equivalent weight of O2 also. Similarly for nitrogen also, because nitrogen will form nitride. Nitride as in nitrogen in -3 oxidation state. So from 0 it is going to -2. I hope everybody is getting this. Again, a good type of questions. हाँ बेटा, just I guess बेटा, we are there in 27 slide, no? Just I'll be discussing the balancing, some questions on balancing and a few questions from titration. So I guess another half an hour I'll take. I'll be wrapping up in another half an hour. But now I'll be having questions, है ना? चलो, moving forward. Now, moving to balancing the statement I have written, how to balance in acidic medium and how to balance in basic medium. Most of the questions of balancing are done once you balance a reaction by basic oxidation number method. Sir, how to balance using oxidation number method? First, let me tell you how to balance using oxidation number method with this basic example, because I guess this is a question from your NEET examination only, because for your NEET examination, oxidation number method generally works for balancing. Let us do it. Sir, manganese MnO4 minus is reacting with oxalate ion and forming Mn plus 2 CO2 and water. So MnO4 minus as in manganese in what oxidation state? +7. Converting to manganese in +2 oxidation state. So what is the electron transacted? Sir, 5. Carbon from, I guess this is 2x minus 8 equals -2. So 2x is +6. So x is +3. So carbon from +3 is getting to +4. So what is the electron transacted? So 3 to 4 as in 1, but oxalate is having 2, so this is 2. So how many electrons are from +3 to +4 as in how many electrons are lost by carbon? So 2 electrons are lost. How many electrons are gained by manganate ion? Sir, 5. How this transaction can become equal? Bring 2 of these and 5 of these. As in, sir, MnO4 minus giving us Mn plus 2. Sir, C2O4 2 minus giving us CO2. So manganese is balanced. Here I have 2 carbons, so definitely I have to multiply a 2 over here because carbon needs to be balanced. Now, whatever is the transaction, sir, here transaction was this manganese is gaining 5 electrons. So I need to multiply 2 because 2 into 5 will become 10. So that 2 I have to multiply with manganese. I have to take 2 of these species and obviously 2 of these species will be formed. Why I require this 2? Because 2 into 5 will be 10. They are transacting 2 and therefore I have to take their 5 species because 5 into 2 will make the transaction even. So I will have to multiply that 5 over here, and similarly into 5 will be, sir, 1 was producing 2, so 5 will be producing 10. So this is how you are balancing the ions. After that, if the medium is acidic, balance the charge with H plus. If the medium is basic, balance the charge with OH minus. So here LHS is -2, 5 2 are 10, so LHS is -12. This is 0 and that is RHS is +4. What is the medium, sir? Medium is acidic because it is H plus ion. So, sir, plus ion will add plus. So, where shall I add plus? Here, because the here charge is -12. I want charge over here to be +4. So, +12 and more 4. That means +16. So, +16 H plus I want, because that will make the charge equal. I hope everybody is clear with this. What next, sir? Now balance hydrogen. How? By adding water. How many hydrogen I have over here? 16. How many hydrogen I have over here? None. So I'll add water. How much water? Sir, 16 I need. So 8. Now I guess this is simplified. Yes, sir. So what are we asked in this question? This is balanced reaction. So for MnO4 minus, coefficient is 2. For MnO4 minus, coefficient is 2. For C2O4, for oxalate ion, coefficient is 5. Option B. I hope you are done. So this is one method. What is the other method? Ion electron method. That ion electron method you can even skip for a NEET level of examination, but beta, because we are expecting the examination to be good, so I'm giving you ion electron method. Ion electron method is just, once you are doing it in basic medium, you need to do one more step. So directly giving you ion electron method in basic medium. Like for example, Cl2 is transacting to Cl minus and ClO3 minus. How to balance this using ion electron method in basic medium? You should know this. Sir, write the 2 half. So Cl2 forming Cl minus. First, in ion electron method, using ion electron method, first balance atom, so multiply 2. Atom is balanced. After that, if there is no oxygen or hydrogen, balance charge using electrons. So minus 2. So I'd add 2 electrons over here. That means this is reduction half and it is simply balanced. Now let us write the oxidation half. Who is getting oxidized? Sir, chlorine only, because this is the only reactant, is getting transformed to ClO3 minus. So 2 chlorine, so I'd add a 2 over here. Now to balance oxygen, add water. 2 3 are 6, so I will add 6 water because it will include 6 oxygen, so oxygen balanced. Then for hydrogen, add H plus. So 6 2 are 12, so I need 12 H plus. But sir, you said medium is basic, so if the medium is basic, proceed till here, but after that add equal number of OH minus ion on both sides, because mathematically it will be same. H plus and OH minus ion, we definitely know they love each other. So whenever you write H plus OH ion, make water. Then simplify water. I hope you can see you have 6 water over here, 12 over here, so 6 will be remaining. And after that, balance charge using electrons. So here charge is minus 12. Here minus 2, and this is neutral, so charge is minus 2. So where shall I add electron? On the right side. How many electrons I should add? So this is 2, so I need 10 more electrons, so 10 electrons. So this will balance the charge. Once charge is balanced, now you can add them. Sir, how to add them? By equating. Again, sir, electronic transaction has to be equated. So this guy is gaining 2 electrons. This guy is losing 10 electrons. So I multiply this reaction by 1. Why? Because 10 into 1 is 10, a bigger number. I multiply this reaction by 5. Why 5? Because 5 into 10 will be 5 into 2 will be 10. So the transaction of electron is satisfied. Now add them. Because I'm first right left hand side, so 5 into electron transaction will be done. So 5 into Cl2 is 5 Cl2. LHS of first reaction is done. This is reduction half, this is oxidation half. This is Cl2. So 5 Cl2 plus Cl2 will give you 6 Cl2 plus 12 OH minus. I guess LHS is done. Gives 5 into 2 is 10 Cl minus. RHS of first is done. Then plus twice of ClO3 minus. Then this is 6 water. I hope it's balanced. But I guess this is further simplified because this is getting cancelled by 2. So this will become 1. This will become 3. This will become 5. This will become 6. And this will become 3. So this is your balanced reaction. There are many reactions which you cannot balance using oxidation number method. So for that, those reactions you have to use ion electron method. I hope everybody is clear. I hope everybody is clear. Chalo. Okay, perfect. Chalo, perfect. Beta, on 19th, I'll be coming with I guess later part of physical chemistry. If you want me to be specific about certain topics, then once this live is done, hit me in the comment section. I'll be definitely watching those comments, and if I get more of the similar type of suggestions or request, I'll be definitely coming to serve those requests, or else I definitely have a planner. I'll be first finishing few physical chemistry areas and then I'll be moving to organic and inorganic. Okay, chalo, moving forward. We are almost done, beta. This is also a JEE advanced question, 2014 question. This you can only do once you know how to balance using ion electron method. That's why I will not be taking it right now, because we have already exceeded so much of time. And yes, last but not the least, we are just finishing in another 10 minutes. Last but not the least, although less in number, but whenever these questions come, most of the students leave them. They just fear from that. What? Titrations. What is titration? It's a redox reaction, but whenever we do a redox reaction and we try to calculate the estimate the concentration of some unknown species, this is also termed as volumetric analysis. Why it is very important, beta? Because NTA, CBSE, they always expect aspirant to be active in class 12th also, and in your class 12th practicals they already obviously ask you that salt and that volumetric analysis that all of you do in your schools, the Mohr salt volumetric analysis. I hope everybody and most of you have done it. You should do it, because yes, they expect you to pass class 12th. On class 12th, for passing class 12, the 30 marks of your board syllabus is your practicals. So that practical work definitely always include this volumetric analysis. What you do, you have a in a conical flask, you have a concentration of a reagent whose concentration you do not know, but you know the volume. How? You use a instrument called pipette. So you pipette out that much volume of solution whose concentration you do not know. This is generally your Mohr salt. In the burette, you take another reagent, that another reagent. The burette is a graduated, it is a graduated vessel where volume is demarked, and you fill this burette till the level which is saying 0 ml. Now, you add an indicator. Why we use KMnO4? Because KMnO4 is it's a indicator by itself, because it is a dark colored solution. Mohr salt is a colorless solution. As you allow KMnO4 to mix with Mohr salt solution, which is colorless, you keep on moving it so that KMnO4 and Mohr salt get reacts. Sir, what is Mohr salt? Ferrous sulfate dot ammonium sulfate dot 6H2O. What is the active ion? Ferrous ion. Ferrous ion gets oxidized to ferric ion. The oxidizing agent is KMnO4. KMnO4 in acidic medium reduces itself to Mn+2. And once the reaction is taking place, the dark purple color KMnO4 will start to decolorize. As soon as the last drop is filled in and you have no more Mohr salt as in ferrous ion available, then the color will change and you will close the cork. You will close the wall of this burette, and you will read whatever volume of this solution whose concentration you know has been utilized to neutralize this. Now do what? Do not balance the reaction. Do law of equivalence, which is number of gram equivalent of KMnO4 will be equal to number of gram equivalent of this Mohr salt. Number of gram equivalent will be equal to molarity, I do not know, volume I know. Molarity I know, volume required to neutralize, that also I know. So the number of gram equivalent, which is law of equivalence, is actually applied in volumetric analysis. That's why I have spent so much of time in this. I hope everybody get it. Nahi sir, I didn't get it. Let me do an example for you. A very famous, this is a JEE mains question, beta. So you can have acid-base titration also. You can have redox titration also. So this is a question of acid-base titration. We do not have to bother about writing the reaction. Why? Because according to law of equivalence, number of gram equivalent of acid will be equal to base. I'm not writing the reaction. Why bother writing the reaction? Now, what formula for number of gram equivalent I should use? Some molarity volume given, some normality volume given. So molarity volume, whatever. So for base, what I know? Molarity. So for base, molarity into volume into valency factor. For acid, normality is given. So normality into volume. Here valency factor is also not required for acid. So I'm writing acid as 2, base as 1. So normality of acid is n by 10. So valency factor you do not even have to bother because normality is given. Volume is 100 ml. Just keep this in mind that volume here you are using in ml. So here also I'll use an ml. For base, molarity I have to determine m1. Volume 150 ml. For NaOH, valency factor is 1. Answer. Beta, a JEE question. A JEE question. You should know how to do such questions. Chalo, perfect. Moving forward. JEE means 5th September. Again, why I'm telling you is because see, law of equivalence. We have spent so much of time. Why? Now it is being productive. So number of gram equivalent of this will be equal to, but this is not acid base. This is redox titration. So number of gram equivalent of K2Cr27. So number of gram equivalent of K2Cr2O7 will be equal to number of gram equivalent of ferrous oxalate. Remember, we have done for ferrous oxalate also. Now it will help us. Now, sir, here volume, molarity. So valency factor, molarity, volume, valency factor for K2Cr27. Molarity is 0.02. Volume that we have to determine. Valency factor, remember K2Cr27 is an oxidizing agent only in acidic medium. So Cr plus 3. So valency factor will be 6. We have already done that. Now, ferrous oxalate. Now, sir, here weight is given. See. So for number of gram equivalent, what formula you will use out of those 4? Sir, weight upon equivalent weight. So what formula I'll use? Weight upon equivalent weight. So this is 6 to is 12. So 0.12 V is equal to, what is the weight, sir? This is the weight. So weight of ferrous oxalate is 0.288 gram upon. Sir, equivalent weight of ferrous oxalates are molecular mass upon valency factor. Molecular mass is given out to be 144. Upon. Now valency factor, remember, ferrous ion will be changing to ferric ion. C2O4 will be changing to CO2. That means valency factor 1 for this, 2 for this. So total valency factor will be 3. I hope you remember this. Just, sir, now this is one liner. Otherwise it is non-doable. If you do not know these inorganic logics, it is not a, yes, now still here also you have to do calculations, but I hope you got my point, guys. Everybody, I hope you got my logic. Chalo. So this is it from my side. Yes, I have few back titration, double titrations. So this is double titration of methyl orange and phenolphthalein. This double titration, back titration, double titration. I have, okay, what I'll be doing is, but I guess this is more than sufficient for NEET level of examination, but if at all you want me to discuss these back titration, double titrations also, if you ask me, sir, yes, they are very much valid for JEE. Sir, are they valid for NEET? Yes, beta. You cannot say we have not seen any questions from them. We have, but yes, they are very rare, and because they are very rare, but still, as a gut, we feel that 21st June paper will be good. So if at all you want me to discuss them also, so just after this live, we'll obviously be meeting, I guess, on 19th. Tomorrow you'll be having a biology, and just stay tuned with PW NEET English channel. We'll be confirming about the later sessions of physics, chemistry and biology. We'll be coming regularly, obviously, as promised. But yes, keep checking PW NEET English channel for all the updates. If you want any specific revision of any specific topics, I'll be giving this lecture notes, PW NEET English WhatsApp channel. Just go download these notes. If you want to read those double titrations questions, those are also given. If you want me to iterate them for you again, so after the live is done, go to the comment section, hit the comment section. I'll be definitely watching them very closely. So this is it from my side. I hope you enjoyed this. I know most of you will be seeing this in the recorded format, but I want everybody who are seeing this in recorded format also. I mean, I am communicating for all those students who will be seeing later. Beta, try to join these lives in the real time. because that will also give me a motivation, and that will also give you the perfect edge to have a time bound learning environment. And the next time when you will be seeing the recording, it will be a revision, so you can retain these things for a longer duration of time. So this is it from my side. So this is me, Gaurav Singh Arora, signing off. Bye bye beta. Please revise everything properly. Bye bye, have a